A very warm welcome to all the participants present here. Let us start our 3-day certification program. Very good morning to one and all present here. It gives me an immense pleasure to meet you all for this 3-day virtual certification program on entrepreneurial skills and geospatial data management, organized by the Center of Remote Sensing and GIS, School of Infrastructure, Department of Civil Engineering, and Crescent Innovation Incubation Council, CIIC, B.S. Abdur Rahman Crescent Institute of Science and Technology. Due to pandemic situation, we are organizing this certification program through online portal. I hope today's lecture will provide you the knowledge on various entrepreneurship skills and startup skills on geospatial technologies, and also provide an hands-on training on open source software quantum GIS, that is a QGIS. Now I request Dr. Vasanthi Padmanabhan Ma'am, Director, Center for Remote Sensing and GIS, Professor and Dean, School of Infrastructure, to address the participants.
Yeah, thank you, Kanmani.
Yes, ma'am.
So good morning, all of you. It gives me immense pleasure in welcoming all of you for this 3-day virtual certification program on entrepreneurial skills on geospatial data management, which is very important today. So I take this opportunity to welcome the chief guest of today's function, Dr. G.P. Ganapathy, Professor and Director, Center for Disaster Mitigation and Management, Vellore Institute of Technology. I like to thank you, sir, for readily accepting our invitation to be part of this 3-day virtual certification program, and
Thank you.
looking forward to hear from you. Thank you so much, sir. Um, and again, no program will be successful without the participation of various of all the uh, lecturers and other people from industries. So I thank all the participants who have readily come forward to participate in this 3-day virtual certification program. So I hope and I'm sure that this program will be very much useful to all of you. As Kanmani has pointed out, because of the pandemic situation, we have to conduct it online. Hope you will understand this training, and in case needed, maybe after 1 month, once all the situations settle down, we can have this training program here in our campus. So it will also be an opportunity for all of you to visit us and also see our campus. And this program is organized in collaboration with the Crescent Innovation and Incubation Council. And this is a council which is under the ambit of B.S. Abdurrahman Crescent Institute of Science and Technology, which is deemed to be university. And this CIIC has been established as a Section 8 not-for-profit company and registered under Indian Companies Act 2013. So it acts as a one-stop shop technology business incubator for startups that facilitates entrepreneurial and innovative ecosystem to all the stakeholders, including students, faculty members, industries, investors, and society at large. So there are so many faculty startups and student startups established under CAIC. The motto of CAIC is to nurture our society by nudging the entrepreneurs with integrity, sustainability, culture of innovation, and triple M strategy, which includes mentor, money, and market. And within a few years, so many startups have been established, students as well as faculty startups, nearly 10 has been established under this CIC. And for the participants, I like to brief something about this Department of Civil Engineering, which comes under School of Infrastructure. So this department has been established in the year 1984. That is since the inception of this institute. Hope some of you know that initially B.S. Abdurrahman Crescent Institute of Science and Technology has been started as a college, engineering college, which was initially under Madras University and then under Anna University, and which was most sought after engineering college. And then in 2009, we became our own deemed to be university. And this department offers 3 programs as on today: BTech in Civil Engineering, MTech in Structural Engineering, as well as Construction Engineering and Project Management. We have experienced and dedicated faculty members Every faculty member is involved in research, and they have numerous publications in refereed journals. And as on today, we have 100 projects worth 1 crore going on in the department. And this center is also a part of this Department of Civil Engineering. We have another center of excellence for which does research on corrosion, Center for Corrosion Protection and Control. That is another center of excellence. And we involve the students in various construction works in the institute campus. And we new technology, which is glass fiber reinforced gypsum technology. With that technology, we have constructed 3 units, G1 G+2 building in our campus. And student startups under CAAC, we have 2 student startups as well as 1 faculty startup. And around 3 patents have been filed, has been granted, and we have around 20 patents published. So, so that is just a brief introduction about the department. And we often organize various value-added courses and training programs. And I request the participants to always support us in our various endeavors. And coming to the program, this training program gives the participants an introduction to geographic information system technology and the unique kinds of GIS data files that enable such technology. As you all know, most data management professionals are more experienced with the classical tabular data, which is in the form of rows and columns, as we find in most of the business, government, and scientific databases. But here, when it is geospatial data, it has a different structure and function. It includes structured data about objects in the spatial universe and identity, location, shape, and orientation, and other things we know about them. So, geographical data describes an incredibly wide range of objects or business assets. It can be the representation of a road or a building or a property line or a terrain, or it can be infrastructure, hydrology, or whatever we see on the earth. So, all these objects can be described in terms of points or lines and polygons, and tables of these objects constitute the tabular portion of the geospatial data. So with this brief introduction, so with this program will take you through creating of new GIS maps to represent all this geographical information, and also applying the knowledge in solving real world problems. So you will also be taken through the given training on the use of this software, which that the software which we are going to use now is the QGIS, which is an open source software. So we'll be given training on this. We have various resource persons to and today morning we have experienced Professor Dr. G.P. Ganapathy, who will be giving lecture on geospatial technology, mapping to manage. And then we have Dr. Pennan Chinnaswamy from IIT Bombay, who is the director of rural data research and analysis. So he'll be giving a talk on GIS skills for developing new maps and startups. And then our faculty members Kanmani and Kannadasan will be giving hands-on training on geospatial analysis. We also have from Institute of Remote Sensing, Anna University, Dr. M. Shivakumar, and then Rajesh, who is the Technical Director and Business Development Manager from Geo Lightning Services. Then yes, Rajesh Kumar, who is the Director of TechApps Consulting, and Dr. Ayyappan Lakshmanan, who is the Principal Consultant in Magendran Consultancy Services. So I am very sure that this 3-day virtual certification program will be of great use to all of you. Please give your feedback on how, in case if any improvement needed, how to improve this training program. I am so with these few words, I welcome sir again, as well as the participants. Thank you.
Thank you, ma'am, for your brief introduction about the program and our department. Today we have organized 2 lectures in the forenoon session. Today's first topic of the lecture is on geospatial technology mapping to manage, and it's going to be delivered by Dr. G.P. Ganapathy sir, Professor and Director, Center for Disaster Mitigation and Management, Vellore Institute of Technology, VIT, and Vellore. Now I request Mr. Kannadasan sir to introduce the speaker.
Good morning, all. So, Dr. G.P. Ganapathy graduated from the College of Engineering, Guindy, Anna University, Chennai, in India, in the year of 1997, and completed his master's from the same university in applied geology discipline. He completed his doctoral research in earthquake microzonation for the Chennai city at Anna University, Chennai. Dr. Ganapathy served for the Center for Disaster Mitigation and Management in Anna University, Chennai for 8 years as a scientist and carried out research studies in the field of earthquake hazard assessment, earthquake monitoring. Later on, he moved to Center for Disaster Mitigation and Management, VIT, Vellore Institute of Technology, Vellore, Tamil Nadu in India. Dr. Ganapathy served as Director for Center for Disaster Mitigation and Management, VIT, Vellore, from the year of 2015 to 2020. At present, Dr. G.P. Ganapathy is working as a professor at Center for Disaster Mitigation and Management, VIT, Vellore. Sir published 60 research papers in reputed international and national journals and presented more than 45 papers in international and national workshops, conferences, and he has managing editorial and editorial board member for 8 international journals. Dr. Ganapathy sir visited 10 countries, including United States of America and Europe, and presented various lectures on disaster mitigation and management. Sir is Dr. Ganapathy is the point of contact India for the University Space Engineering Consortium Global, and sir is the member for the State Disaster Management Plan Core Group, State Yearly Warning Committee member, and consultant for the preparation of the district level multi-disaster plan from the government of Tamil Nadu. Dr. Ganapathy sir is the nominated member for the Disaster Management Agency, Vellore Districts. He is also the member for District Environmental Appraisal Authority, Vellore and Thiruvannamalai Districts, Tamil Nadu, and member in Drought Monitoring Authority, Vellore and Ronipet District, and District Expert Committee, member Major Hazardous Industries, and member for Districts Wetland Management Committee in Vellore Districts. Sir received a special award for the contribution to District Disaster Management Authority Vellore and received various fellowships like United Nations Office of the Outer Space Affairs, Vienna Fellowship, INAE Fellowship for the Monitoring Faculty in the Landslide Disaster Risk, International Network for Crisis Mapping, Precise Mapper, ICCM Fellowship 2016, etc. Sir handled 14 funded research projects and more than 30 consultancy projects on disaster mitigation and management and mining. Thank you, sir.
A warm welcome to this program, sir.
Thank you, ma'am.
Yeah. Now I call upon Dr. Ganapathy sir to deliver the lecture.
Yes, thank you, Dr. Karmani.
Yes.
First, I would like to thank Dr. Vasanthi Madam for the wonderful introduction and about Abdur Rahman Garaj. I have been there for quite a long time actually, because VIT and Abdur Rahman both are started in the same year, I guess, in the year 1984. And I have visited many times, particularly during my college days in Anna University. We used to come for a lot of cultural activities to Abdur Rahman, and that time we used to call Crescent Engineering College. And even recently we have visited for a disaster mock drill with our Commissioner of Revenue Administration. Even your registrar is our former Anna University professor.
Yes.
You know very well.
Vice Chancellor also from Anna University.
Yes, and
Mohammed sir is also from CEG only, sir.
So all our friends are there, particularly my juniors are there, Kandani and Kannadas and even all the resource persons here in this 3 days program. All are my friends, and thank you for the opportunity. Actually, my lecture might be supposed to be in the next session, but due to I have another meeting with our collector, so that's what I was preponing. I'll start presenting actually. I'll just share my screen.
Yes, sir.
Is it clear?
Yeah,
Yes,
yes,
sir.
sir.
Yes, sir.
Okay. Today I'm going to talk about geospatial technology mapping to manage. I'm not going to talk much on the skill development today because other, the resource persons, they are going to talk detailedly. But what I would, focusing much on the current important things in disaster management, how this geospatial technology is going to be a major part and how we are using currently. I'll just discuss few things about general and then I'll go for what we are doing in VIT as well and how we are effectively involving in disaster mitigation and management aspects by using geospatial technology. Generally, in any entrepreneurship skill, uh, uh, you know, comes when you are, strong in something very specific. So unless you know the subject very strong or the fundamentals, then you can't be excel in any entrepreneurships, and that's why the any basic fundamental will be very very important, particularly geospatial technology. If you know how to use it, it is going to be a very useful tool. If you don't know how to use this tool, then it will be a very very dangerous tool. So that was I always says, like when you give A plus B, then it will give C. So we have to be very very careful when you're using this geospatial technology, particularly in analyzing any kind of interpretation is very very important. Okay, so what is geospatial technology? So as everyone knows, we have a GIS, spatial analytics, by using desktop, web or cloud, and mobile applications we have, and GNSS and positioning. We can have navigation, indoor positioning, surveying. Earth observation can be done by satellite remote sensing, aerial mapping, UAVs, and scanning by lidar, laser scanning, and radars. So all these technologies are very very useful technology in these days. Particularly the recent technologies like earth observation and scanning is going to be a very very I can say it is a boon to the geospatial community, because we can have a very wide range of analysis, particularly in case of a disaster management. So this geospatial technology you can apply in many areas, as Madam has pointed out. So you can apply in logistics, transportations, meteorology, forestry, agriculture, healthcare, ecology, marketing and advertising, real estate, insurance, and what I'm going to focus is on disaster mitigation management. So geospatial technology mainly, we look for data. So data is very, very important. It may be a satellite data, or it may be a primary data, or it may be a secondary data. So data. So when we talk about any geospatial technology, we need to have a quantum of data. It may be uh, uh, geospatial data. For example, if you want to have a climate and weather data, we'll have a surface temperature data. This data may be available. You can just check in Moody's, Aster, AVHRR, and Lancet thermal data are very much available. For climate, you can have a NLDAS2 and GridMet data is available. And atmospheric data, we'll have a ozone data from NASA, storms and OMIS instrument, and Moody's monthly gridded atmospheric data is available. For weather data, again NOAA global forecast system, GFS data is available, and climate and weather data, Landsat data is available, Sentinel data is available free, Sentinel 1A and 1B, and high resolution optical images are available, and Moody's data is available for moderate resolution imaging spectrometer. This is very much available for 16-day BRDF adjusted surface reflectance and derived products such as vegetation index and snow cover, and other high resolution satellite images. For example, if you want to go do some sample data analysis, any open source data, you can download this data from US at 1 meter resolution. You can have a data from 2003. And the other data, like, it's not really a geophysical data, it's a terrain data, mostly the physical features of the earth. You can have a terrain data, like digital elevation models are available from SRTM data, and land cover data also is available from Moody's, and cropland data, you can get data from many layers. You can get from global food security support analysis data, GFSAT, uh, and crop dominance, and other data like nighttime imagery, defense meteorological satellite programs are available, and DMSPOLS, what we call, and this data can be analyzed. So you have enough number of data in free platform, which is available all over the world. In when you Google it, then you can get all data. But what we need to know important is how to use this data properly. So what kind of data can be used for what purpose, and how effectively we can use this data in particularly I'm going to focus much on disaster mitigation and management aspects. And before going into detail, like, I'll just give a glimpse of what is disaster, because the audience are a little bit you know uh, multi um, uh, multi departments. So disaster is nothing but an impact of a natural man-made event upon a vulnerable community, resulting in disruption and damage and casualties which cannot be aided by the locally mobilized resources. So the definition itself, it conveys, right, if it is not possible by the locally mobilized resources, when you are calling assistance from the other agency, then we will call it as a disaster. So why I'm linking this to geospatial technology? So each and every word, if you see in this, disaster definition, it is going to relate with your, disaster, the geospatial technology impact. For example, impact. So you have to do the impact analysis. Natural or man-made event. It means you have to do some kind of, you know, uh, satellite imagery analysis for that. Vulnerable community. Again, you have to go to socio-economic analysis. Again, it is going to relate with your geospatial technology. And community resulting in disruption and damage. Again, you are going to relate with post-damage analysis. That again, satellite data you are going to use. And locally mobilized resource, again, resource allocation also is possible by using geospatial technology. So each and everything in disaster we are going to link with geospatial technology. That's what we are going to do. And why again it is important, because we need to understand the disasters properly. Unless you understand properly, you're not going to use this technology properly in the disaster mitigation management efforts. So rapid and slow onset of events. Some of the disasters, like, very rapid, like earthquake, it may happen in within seconds. So what we can do, how this geospatial technology is going to be useful in case of an earthquake. So we are not able to predict earthquake as of now, because we don't have a technology to predict earthquake, but we can use this technology for some kind of post damage assessment, or kind of precursors that can be possible. And the slow onset events like cyclone or a flood or a landslide. So we can use this technology for slow onset events, because we have enough time, like it may we have a preparedness time. For example, cyclone maybe 10 days time you can have, flood maybe you can have 4 or 5 days, very good time to prepare yourself, so that you can identify the areas where it is going to happen and how much area is going to inundate, and what kind of data you can use, the existing data, and how you can effectively use this technology to prepare yourself for a disaster. And another one is like the frequency versus severity. the frequency of the event, like, earthquake may happen 100 years once or 200 years once, but the flood or a cyclone, it may happening here in, particularly in countries like in India every year. So frequency may be very high, but the damage maybe it may not be that much. But the severity is very, very, high when in case of an earthquake. So again, this also will give you a clue. So how effectively we can use this technology, because we don't have a prediction mechanism. So where we can use this technology, and the mitigation measures to withstand the impact and avoid the impact. So again, for example, you can identify the areas which is prone to earthquakes. So this is one thing, like, you can use your geospatial technology again, and so that you can avoid the impact of the area. Or if you go for withstand the impact, so you can go for the earthquake resistant design and other things, and the study area. So urban area and the rural area. So the impact we always, evaluate based on the buildings and the people. So say example, there's both are the things in this pictures, like the left side there is a village and the right side there is a city. So village maybe a same 50 square kilometer area, and city also 50 square kilometer area. The number of buildings in this village is only 40 or 50, but the same 50 square kilometer area you are going to have 5,000 buildings over. So the study area is going to be play a major role when you are going to assess any disaster informations. So again, this geospatial technology is going to play a major role. It's a very, very time bound tool. So very useful tool when we are going to use during any major disaster events. Okay, so where we can use this disaster management, to this geospatial technology in disaster management. It's a very useful tool. One is like, when the disaster happened, there is a post-disaster event and the pre-impact event. So pre-impact is nothing but your mitigation and preparedness, and the post-disaster is nothing but the response and recovery. So immediately after the disaster, then you are going to have the rescue operation. So geospatial technology again is going to be play a major role in rescue operation, because I will show some of the pictures, like, how we effectively use the geospatial technology by using satellite images for rescue operation during Nepal earthquake. So we have been participated in 2015 Nepal earthquake, that I will show you later actually. So you can use the satellite data for rescue operation. And also you can go for the quick relief operation, because relief also major issues, like, where you have to distribute the material, how to locate, identify the suitable location for keeping the relief material, and how to transport this material, what is the optimum route analysis. So all these things you can use geospatial technology, particularly in case of an emergency situation. Also the reconstruction process, again geospatial technology is going to be play a major role, particularly identification of the suitable location of building, restructures of the damage affected areas into from the disaster affected areas. Again, the mitigation plan also you can do by using geospatial technology and preparedness. Both are very, very useful. I'll just move on to right now how we are using all these things. And the post-disaster, you can go for disaster monitoring, immediate response, relief, recovery, impact study, and rehabilitation. And pre-disaster, you can go for vulnerability analysis, preparedness, warning, forecast models, and vigilance system. And I'll just give some of the examples, like, how we are using this technology really. Because earthquake is not possible to predict. We have two kinds of earthquakes. One is interplate earthquakes, other one is intraplate earthquakes. So intraplate earthquakes, generally people they monitor by using keeping the GPS in the two side of the plates, and that's what currently we do in all over the world. But the intraplate earthquakes is another one, like where we have a fault system in your area. Say example, within a plate we have a number of fractures. Say example, within Tamil Nadu we have a number of fractures. So these fractures time to time they'll move, so they will reactivate to each other. So this is a kind of a relative movement it will give. So what we can do, we are not able to predict how what magnitude earthquake is going to happen. or where it is going to happen. Prediction in the sense when, where and what magnitude earthquake and what time it is going to happen. So unless you say prediction like this, it is not going to be useful. So, but what we can do, we can have a kind of precursors. So we can go for a cassette fault mapping. So suppose if you have a fault, okay, you can have raster images and monitor this fault. So we can monitor the vector field. So which direction the stress is accumulating. So in a particular point, when the stress is accumulated, you can assume that this area is going to be a more stress energy is going to accumulate, and particular point it is going to release the strain energy. So that is the one way we can identify the location where you have the accumulation of stress. And SAR interferometry is another technique people nowadays they are using for cassette fault mapping, using again in a particular place, like point in a fault, how the stress is accumulating and which direction it is moving, and also you can identify in how much depth it is going to subside. So that is also another thing, like now people they started using the relative displacement of an area by SAR interferometric technique. And radar signals. Radar signals also will give an idea in a disturbance, like in a particular fault system. The normal radar signals will be different from the fault area whenever there is a signals crosses over there in a fault area, because this area undergoes some kind of relative movements. And another one is like surface latent heat flux. So when earthquake energy accumulate in a particular point, there will be a heat energy forms. So by using this heat flux maps, surface heat flux maps, particularly in case of interplate earthquake areas, like interplate earthquake areas like plate boundaries. So the heat flux energy is accumulating more and more. So that can be identified from thermal anomalies. And you can go for hazard assessment by using your geospatial technology. Maybe in your hands-on exercise they may teach this. Actually, suppose um, because earthquake is not predictable, but what we can do by using deterministic seismic hazard assessment, you can identify the areas which is prone to earthquake. For example, in this map, I have put some kind of linear features, that is nothing but the faults over here, and I've calculated some peak ground acceleration value. Suppose you can see this red color, orange color, yellow color lines are there. So there is some value 0.331, 0.391, 0.33, 0.255 like that. So it's nothing but, so this is the maximum peak ground acceleration that a fault can generate in future. Assume if there is going to be a maximum magnitude. Suppose there is a fault in this area. If this fault is going to generate a magnitude of 4.9 or 5.9 like that. So how much energy it is going to release? So what you can do, you can digitize this faults from satellite imagery. So what you can do, you can go for analysis of lineaments from satellite imagery by using Landsat image. So you can identify the lineaments. Then later on you can go to field and identify whether it's a fault or not, whether you have a relative movements. Even from satellite image, you can identify in some of the relative movements if you have a linear feature, is there any disturbance in that, like a river running in a particular direction may get changed. If you have a litho contact in a particular area, that may be a lineament. So by like that you can identify the areas, and later you can digitize those lineaments and you can bring it to the GIS, and you can put a buffer. See, I'm just putting a buffer over here for approximately 5 kilometers each, because if there is a fault, so this fault may be ruptured for 5 kilometers each side. So that's why I put 5 kilometer buffer over there, and totally 10 kilometer buffer. So from that location, if there is going to be an earthquake which is going to energy release up to 0.255, it means how much distance it is going to cover, because we have number of sources. Say example, I am in Vellore. Okay, so Vellore is here. So I want to know, we have so many earthquake sources nearby, but which earthquake, which fault it is going to generate impact to me. So like that, for example, this is a Coimbatore fault, 6.5 magnitude earthquake it has generated. 6.1, actually 6 is the maximum magnitude. So we'll keep maximum side is 6.5 is the buffer. We keep it. So 6.5 is the maximum. So we can generate peak ground acceleration by using this formula. Ln y equal to C1 plus C2 minus 6 plus C3. Like this C1, C2s are values are given over here, and R is the epicenter distance. It's nothing but from, for example, Vellore is here. From Vellore to this point is the epicenter distance. Okay, so that we have to calculate. And so based on that, we calculate the peak ground acceleration. Suppose peak ground acceleration 0.331 for Coimbatore. This fault, if it is going to generate an earthquake of 6.5, it can generate 0.331 is the peak ground acceleration. So for Vellore, I am suppose here for this location it is 0.003. So I need not to be worried when there is an earthquake in Coimbatore, because this energy is going to be die and it is going to reach value. So I can design my building accordingly. I have number of faults over here. So based on that, we can identify which fault is going to generate more earth. So we can have a combined hazard. So that's what people they used to have a methodology. And the second thing is like, you can go for further little more information on microzonation, what we called by using geospatial technology. So like, why microzonation is important, because, if you feel earthquake one time over there, like, people, places like lakefill areas, normal areas, you will feel earthquake 2 to 3 times more in a filled up soil. Suppose this is the area where you have a lake. So that lake is not there currently in Chennai. So this area is filled and they have already constructed houses over there. So these kind of areas will feel earthquakes 2 to 3 times more. So soil get amplified. So again, your geospatial technology, it will give a very good, useful idea to interpolate the data. You can identify the areas where it is prone to this location, and you can use subsurface soil profiles and other things by using SPT, N value and other data. You can identify even more, detailed information on this area. So you can interpolate the data by using geospatial technology by, say example, this is the area. So different area, if you have a borehole data, you can analyze the borehole data. If based on the shear wave velocity, you can identify the area more, accurately compared to the regional study. Like, here we can study based on the peak ground acceleration value, which is bedrock level. But what we are going to do here is up to from the bedrock over that you have a soil amplification. So suppose here if you are feeling 6.5 magnitude earthquake means the over that it will add additional zero 0.5. So it is going to equivalent to 7 magnitude impact. So that kind of analysis you can do by using geospatial information. The other one is whenever we go for any scenario, say if you want to identify area which is going to be prone to earthquake in future, how much it is going to impact. So you can go for critical facility analysis and high potential loss facility analysis. So you can locate this hospital, medical clinic, schools, educational institution, all these things in a map. And the cascade effect also you can calculate from the dams and levees. Suppose if you are going to have an earthquake, so if there is going to be a dam failure because of the earthquake, how much water is going to release, all these things you can calculate. And the lifeline inventory also you can calculate, lifeline utility also you can calculate. So all this information you can have idea, and you can use this kind of simple rapid visual screening process. What you need to do is you can identify the buildings by using by digitizing from high resolution satellite data. Even you can use your Google map is more than sufficient for that. So based on the available information, you can identify this. This can be done by any even undergraduate students. So you can identify the buildings by shape. So rectangular building, it may be a L-shaped building, U-shaped building. All these buildings you can have a you can digitize from your GIS, and maybe you can use from QGIS, or you can use the ArcGIS tool, and you can add the field attribute data. Like, suppose if I have a L-shaped building. So where it is going to be, I can give some kind of score values over here. So like this, like, in this map, you can find it out. We have a score values. So if you identify this is a building, so I can digitize the building. I can give the basic score over here, 3.5. Whether it's a mid-rise building or high-rise building, I can calculate. Suppose if it is a high-rise building, minus plus zero point 0.4, like that I can give. High rise building, there is a value, each value you can, and vertical irregularity is nothing but whether the building is vertically safe or not. That also you can identify. Horizontal irregularity is nothing but whether your plan is L shape. That is nothing but the aseismic building. So that also you can identify. So when if I want to do each and everything in a field, it's very difficult. So what I will do, I can digitize the map. I can just like click over there in one, for example, one building. I can add information, multiple number of information over there, and I can add all the score values in all the score values which is given over there here, and I can enter the value. So I can easily calculate by adding the value in query builder, and I can just say if my value is less than 0.7 here. So what I can find it out, like, whether my building is safe or not. Okay, for an earthquake situation. So this is nothing but the rapid visual screening of building. Suppose if I want to do as a survey by using total station or anything else, so it will take some time, maybe 1 month or 2 months or 3 months time. But in case of if I use the satellite data, maybe high resolution satellite data like QuickBoard, or even you can use your Google data, is more than sufficient for this kind of exercise. So the benefit is here is I can say, like, instead of telling, like, here it is 5,000 building totally, all 5,000 buildings is prone to earthquake. No. So only out of this, only 10 to 15% of the building is prone to earthquake. I can identify based on the score value, because I have entered the score value here, and visually I can see which are all the buildings are prone to earthquake, and I can say, like, further evaluation and recommendations. So these buildings are going to analyze further and go for retrofitting. And this is what we do classification. So yeah, score value less than 0.3 means this building is high probability of grade 5 damage and very high probability of grade 4 damage. 0.3 to 0.7 high probability of grade 4 damage, very high probability of grade 3 damage. And 0.7 to 2 high probability of grade 3 damage, very high probability of grade 2 damage. Like that you can analyze. So what is grade 1, grade 2 damage are classified over here. Like grade 1 means negligible to slight damage, no structural damage on the building, and 5 means destruction, very heavy structural damage as well. So like that you can identify, because it's a very cost effective, and you can, anybody can use this technology. If you have basic knowledge in digitization and doing some score value, then it's more than sufficient to analyze this kind of buildings. And but whenever we do this kind of exercise, but it is not sufficient for us. But what we can do, we can go for a scenario analysis. If there is going to be a higher magnitude earthquake, for example, this is the fact sheet which we are using is, for example, zone 3. Zone 3 means moderate zone. You can expect a magnitude up to 6.9. For example, Chennai, you can use this form. So if it is in zone 4, you have to use a different form. Zone 5, there is a different form. So each form you can use it. This is one thing. And but it is not sufficient, because I am working for, if I am in Chennai, I am using zone 3 form. But what happened in case of we have a higher magnitude earthquake? Zone 3 means we can expect 6.9, but what happened in case of 7.5? So that is another major issue what we what we have always, because earthquake is not predictable. So what we can do, we can go for a damage analysis. We have done using some HASS methodology by using GIS actually. So this is the additional tool you can download from internet called HASS. Actually what we have done, because HASS is nothing for US. So we have downloaded the HASS software and we have customized the software for Indian condition. And what we have done, like, we have calculated the damage for different magnitude, 6 magnitude, 7 magnitude, 8 magnitude earthquake happen. How many buildings will damage, that we can calculate. Even we can go for the emergency centers which will damage. When we have to open the emergency centers, everything you can calculate from the HASAS methodology. And now the people, they are started using monitoring of earthquakes by using geospatial technology, and flood warning also they are doing, and landslides they are doing. Similarly, like INSAR imaging for landslides, aerial photos they are using for landslides, and particularly lidar imaging they are using for landslides, because all these things are latest technologies, emerging technologies, particularly for analyzing the 3D visualization of the landslide impact areas. And also, like this is a Malin landslide in 2014. We have used unmanned aerial vehicle during that time, and to identify the areas like which is totally, actually this is the area, it is totally washed away, and we want to reconstruct the area, like how it is previous and what happened. So for that purpose we have done the unmanned aerial vehicle over here, and we have captured the data by using acute 3D. Even in this you can use for by 3D visualization, you can calculate the volume of material which is removed from that. You can calculate the distance, you can calculate the height difference, everything you can calculate from this tool by using GIS as well as the acute 3D. And cyclone warning you can do actually. So nowadays, like, it's open tool, it's available, it's called Zoom Earth. So you can go and check, like when the cyclone is formed, how it is moving. So everything, like when you have a live satellite data, you can analyze and you can monitor the data quickly. And also this is the NDM, what we call National Database for Emergency Management. This whole database is maintained by ISRO, and here you can collect all the information about the disasters, which is having live information. You can get it, how much the currently rainfall, that information also, which are all the vulnerable location. In when you go to Indem portal inside, actually there is a login and password, but this will be given only to the district authorities and state authorities. So when they log in, then they'll get all the information, like what all the nearby facilities are available, which area is prone to earthquake, landslide, everything is there in this NDM portal. And also these kind of apps are already available by using GIS. So everything is based on, the background is GIS. Wherever you go, the background is GIS. This open tool which is available, TN Smart, by the government of Tamil Nadu. So you can identify here over, you can install this and see, view disaster alert, weather forecast is there. You can find it out, the current rainfall and the observed rainfall. The satellite images by ISRO, it is given over here, and the vulnerable location, it is identified by GIS, and daily you can see how much is the rainfall, that also by location wise. So this information is broadcast from Thailand. Actually, there is a RHYMES project in Thailand. So they do everything based on GIS actually, and the whole information lively they are transferring to TN Smart. And the another one is Indra Vajra. Here you can find it out in current, lightning. So next 15 minutes, how you are going to get a lightning from nearby area, that can be identified. And how we use actually this effectively use the geospatial technology for disaster management, particularly quick response. Actually, I'm just giving a one case study. Another 5-10 minutes, I'll finish it up. And what we do, like we get the satellite data, raw satellite data. Actually, nowadays you can get many data are freely available, but 5-6 years before it is not possible. What happened that time? Actually, there is a program called InnoSat program. So UN operating satellite system. So what InnoSat will do when there is any major disaster happen in any part of the world, so they geosynchronize the satellite. They orient the satellite to the particular location, and they take the satellite data and give it to us. So what we have to do is we have to raise the data request. So UNOSAT will give the data for particular location. They have a project. So we request, say when 2015 Nepal earthquake happened. So I raised the query because Nepal is a poor country. very less people there working in Nepal on space technology those time. So we requested the satellite data. We have a group of people called crisis mappers. The crisis mapper group was a Google group actually. So we have a people from 42 countries. So in different part of the world, we have a group of people. So whenever there is a disaster happen, immediately we start working on that particular disaster. We'll start, trying to help people. So what we do, we ask data from UNOSAT. UNOSAT will give the data. So where the UNOSAT will give the data, UNOSAT will collect the data from DigiGlobe. I think everybody knows, those days, DigiGlobe is the Google map provider for Google, right? So Google don't have their own data, so they will collect data from DigiGlobe and they will give it to us. And now Mexa technology they are using actually. This DigiGlobe data is a real-time data. Every 1 hour data we get it actually. So what we do, we get a raw data. From the raw data, by using image processing as well as GIS, we can digitize the area. We can identify the worst affected area. When we get some kind of hands-on information, immediately we will transfer this data through our social media. We have a Google group. All our people, for example, we work 24/7 method when there is a disaster happen. So, for example, myself, I'm from India. I can work from 10 o'clock to evening 8 o'clock. Then I will give my data to my friend who is working in US. So they will work during night time. Say example, Nepal earthquake happened. We identify some people from Nepal who's working in US. So we give the data to those kind of students. They try to help us during disaster time. So we get the data, and that one it will go to internet, and from that we'll have a social. The analyzed data will be transferred through social media. We have NGOs in the local for example, in Nepal, we have NGOs. Through WhatsApp, we transfer the data to the local NGOs. They use this data to, help the people to rescue. So how we did it? This is what happened in Nepal earthquake, 26th April 2015 Nepal earthquake. So this is the location when there is an earthquake happen. Then continually we start monitor, and this kind of high resolution image we can get it from DigiGlobe. So this is the pre-image, this is the post-image. Immediately after the earthquake, we get the image. This is within 1 hour. So it's a real-time data. So only UNOSAT can give those days. But now the international charter can give the data. But again, it will take some time. But we don't get exactly immediately after the disaster. Sometimes, when we request through government, then government can able to get the data. And this data will give an idea, how many, which area got totally damaged. So for example, here, this tomb is damaged, the total area got blocked. So this road is got blocked. And which road is, here also you can find it out, totally collapsed buildings. Here also totally. So we superimpose the other layers. We got the socio-economic layer from those people, and we also identify how many people approximately in this location, where to these people are there, whether they are stuck inside. So exact location and how to move these people, all these things we can plan. So without going to Nepal, I can plan over here from Vellore. And this what we do, what we call this rapid damage mapping. So UNOSAT will give a raw data. So we have to identify through their website, and by using image processing. Why it is important? Because Nepal, for example, Nepal is the linear structure, the whole country will be like a linear structure. Whenever there is any disaster happen, people they concentrate only in cities. So but what we understand is, other than city area, also many places it is worst affected, like Pokhara, Kathmandu, Bhaktapur. So this area got highly damaged. So by UNOSAT, quickly we can do the rapid damage mapping, so that we can identify which are all the area are worst affected. So we can just put a you know rectangle over there. Then we'll go for detail mapping like this. So in the right hand side you can see 29/4/2015, 27/4/2015, like that, 26/4, so 25/4/2000. So these are all the data which is for available for immediately after the earthquake. So 25th April is the before before disaster. 26th April is the earthquake date, and 27 April date. So all this data information, like every 1 hour data we get it. So what we can do, we can just click over there and we can identify whether this building is totally damaged. So we can quickly identify, for example, red color or partial damage, violet colors are total damage, yellow colors are less damage, like that we can identify. So this will give an idea, like, quickly where we can deploy our rescue operation people. So the geospatial tool is a very, very useful tool when we are assessing this, because you don't need to waste much time, because this area is totally collapsed. Where you have to locate, where you have to allocate your resources in that particular location, and how many people approximately they might have stuck over there. So everything you can find it out. So this is what we have done. Uh, this is called NGA damage assessment for different part of the location of Nepal. We have done it, and violet color is destroyed, red is major damage, orange is minor damage, and yellow is affected areas. And this what we get another high resolution image from CNS data. During that time, we calculated, like, suppose if you have a high resolution data like this, so if this road got blocked, we have to go for alternate route alignment. And how many people, even some of the areas, we can identify the shelters over there, like, how many open spaces are there. We calculate the open space area, total area. Even we have a friends from other countries who came to help. So they want to put the medical clinics over there. So what we have done, we have identified the safe areas over the here by using image satellite data and GIS, and we calculated the area. We calculated the tent size of the shelter, how many people they can accommodate. Everything we can calculate from over here, and we have done it. And this is what we have done during 27 April. So these are all the shelters. They put it over there during that time with the help. Actually, we have a team actually of people from Crisis Mapper. We worked during that time. So we didn't do anything like very, very big, but what we have done is, like, simple information we collected, we collated, and we put it in the website by using GIS. Another thing is social media listening. During Kerala flood, actually we have done with one of my friend from analytics. He is working in Chennai. So these are all key influence. Actually, what we do, like, we collect data by using artificial intelligence and geospatial technology. We will create a heat map. So these are all the people when they tweet about with this hashtags, we can identify the location of this people, and we can create a heat map, which area it needs more relief, so that we can allocate the people to particular location. So you can find it out with the help of there is a group of people we worked during this time. We have identified the water inundation areas for different dates with the help of IWMI from Sri Lanka, and from ISRO, from International Disaster Charter. All these people, we work together, and we identify the areas, and we collect the data and superimpose over the land use map of Kerala. And we can identify the quick damage assessment to the Kerala government. Actually, we were part of the Kerala's CM committee that time for post disaster need assessment, because how much need is there for further flood after 2018 flood, in case of relief material, in case of damage on crabs, everything we calculated. Even we calculated some of the road damage and road blocked areas. Everything we calculated during that time by using geospatial technology. And JAXA data, actually they have given from IWMI during that time. And same thing we have done during even Chennai flood. We have helped our government, and as well as to Kannur district and Chennai districts. And uh, uh, I'll conclude my presentation in next 5 minutes. One important thing, this is nothing but nothing to do with the geospatial technology, but what I want to convey is our traditional and indigenous knowledge are there. This knowledge should be used properly to handle any disasters. And this is the one technique called earthquake resistant design, which is in used in Japan actually. This is a temple actually which crosses more than 1300 years old temple. There are more than 1000 earthquakes happen in this area, but none of the earthquakes damage this temple. But the temple architecture is from learned from India actually. This kind of the architecture came to India. He learned this technique and he implemented over there in Japan, but currently we don't have this technique. And another one is baobab tree actually. See, those days there is no satellite data available. People, our forefathers are very clever and they just see this baobab tree, and when the tree is drying from the bottom, it's going drying from the bottom to up. It means that area is undergoing drought. So they don't have a geospatial technology or any technology those days, but they use their common sense. They identify the areas. And this is another one called Yamlahawk bird in this area. Like, whenever there is a flood in this area, this birds can shift their nest from bottom to top. It means the water is going to come in this river, so it will transfer. So how birds are having the idea, like, how much water is going to come. And flood protection also they have done using Waju. There is a plantation called Waju. Whenever there is a river meandering is there, one side there will be erosion, other side there will be a deposition. So that also can be identified and stopped. And mangrove forests, everyone knows, like, this will be very good for tsunami protection. The roots are very, very deep, and so it will reduce the velocity of the tsunami wave, so that will be get saved. And another one, like, now if we are talking about early warning system, in those days itself in Tirunelveli, in Tamil Nadu, there was a Sangukal Mandapam. So in this area, when flood water comes, the wave, the wind will go crosses when it crosses over here, and there is a sangu conch, what we call in English conch, Tamil sangu. So when it crosses, when water level raises, the sangu will give a sound, so that it will like alarm the people nearby the river bank. They all evacuate, and once the water level is receding, the voice will be the sound will be reduced, so the people will come back to the location. So this kind of indigenous knowledge we have in our India. And this is another location. This is my native place. Forefathers are very, very clever actually. This is a place called Zenji. If you go here, like, they don't studied any satellite technology those days. They identified the location where, so this area is prone to drought area. So for drought you need to have food and water. So this pond they have made such a way that 365 days in a year you will get a water. So what they have done, they are connecting all these river channels over here in nearby the hilly area, collected the water and put it over here. So if you go 365 days, you'll get a water over here. And there is a small, granary over here, so that they'll store food over there. So this kind of, idea, the planning they have in our forefathers. The same Senji fort, this is another part of the fort. Actually, you can see the same kind of structure over there in the top. And there is a small pond over there in the top also. So this area again prone to flood also. When flood water get enter inside the area, so the king cannot able to come down. So they can manage the food and water from top, and they will handle the situation. And this is again the same area. This is what the fort which I have shown: Rani Fort, Raja Fort, and one more three fort. Like, if you go and see here, these forts, how they those days there's no technology. Now we are talking about the optimum site analysis. You can check over there in the one hill to another hill. If you go there from one hill to another hill, you can see Raja can see Rani. So this Rani and Raja, they can be under surveillance with Talabadi actually here. So they have a place over there. There is a small structure, and with that there is a hole. From that hole, if you see, you can see Raja and Rani fort. So such a way that they have planned optimum route from those days. So there is no remote sensing those days, but people, how cleverly our kings, our forefathers, they use this technology. those days itself, remote sensing and GIS technology, maybe we do not know actually. They have a thought like, but they visualized everything and they have done this. And this is another one, temple architecture. Actually, if you go in most of the places in Tamil Nadu, you can find it out. Temple architecture system like that. If you talk, from one place to another place, it won't echoing. So it will be clearly audible. So people, they used for incident command system generally. When there is a war or any kind of disaster, people, they'll assemble over there and they will give guidelines in this area. And another one is like Tanjavur temple, you all very well know. Actually, this is the river which is flowing, but the original river was like this. So our forefathers are very clever. The kings are very clever. They cut the river and they constructed the temple over there, but none of the floodwaters goes inside the temple. So the river management by without using any satellite data. Those is how they have done it. So this is also a big question actually, because our forefathers are very clever, and they have managed very well drainage management system. And this is another one, Rameshwaram temple, you all very well knows. This is in near seashore, and this temple crossed more than 1,000 cyclones over here, but none of the cyclone hit over the temple. If you go and see, like this temple, these are aerodynamic structures. So you might have heard about ambassador car. Those days, like ambassador cars are accident proof. When wind waves comes, it will hit, but it won't damage the structure, right? So similar structure only they'll construct in most of the coastal area. The temples were constructed those days are aerodynamic structures. So none of the cyclones were hit over here in this temple. So our forefathers are clever and they know the history of the disaster in that particular location. They have identified the areas and they have constructed the things like that. And Kallanai Dam, everyone knows, like again, this area is liquefaction prone. So if you see from all these pictures, like what I have shown for last 5 minutes, so assessment. So our forefathers, they are very good in assessment. That's why they are able to construct a dam in a liquefaction prone area. They construct a temple in a cyclone prone area. So they have done an optimum route analysis. They have done an optimum site analysis those days. So without any technology, if they are able to do with all these technologies like what we have currently, if we use our traditional indigenous knowledge with our technology, like geospatial technology, we can excel compared to any other countries. So this is our state emergency operation number, district emergency operation number. We have 1.36 billion brains and 2.72 billion hands. And our destination is disaster risk-free India. Use our technology properly, particularly the geospatial technology. If you are going to use it properly, if you know how to interpret properly from satellite data, it is going to be a very useful information to the community and the individual. And if you know how to handle it, then you'll be a real entrepreneur. Thank you. Any
Thank
doubts?
you so much, sir.
If any doubts, I can clarify. Otherwise, I have a meeting with the collector, so I can leave.
The participants, if you have any queries, you can type the query in your chat box or raise your hand.
Or I can give my
Yes, sir.
email ID in the chat box.
Okay.
Yeah,
So that,
since sir has another meeting, maybe the participants can post your questions. I mean, can mail your questions to sir mail ID so that when sir is free, he can reply. Is that okay, sir?
Yes, ma'am. Yes, ma'am. Anytime they can contact. I'll just post my address over here. So my email ID, phone number, everything is there. So even I can put my Facebook ID also. So if anybody interested, all my research related links, I'll post in my Facebook. So you can find it out. A lot of new technologies, everything I post, like whatever we do, I used to post in Facebook also. If anybody interested, you can look into it. And I apologize. Actually, I have to go for a meeting with the collector.
No problem, sir. We can understand. Okay.
Thank you.
So participants can contact sir through him, through the mail or his contact. Mail ID mailing will be better.
Yeah, okay.
Thank you so much for your very informative lecture. Really, I'm very happy to see so many projects you have undertaken. Very nice, sir. So I'm sure that participants are benefited from your lecture. I'm sure about that. Thank you so much, sir. We'll meet again.
Okay. Thank you, ma'am. Thank you.
Thank you. Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Dear participants, the feedback link will be posted at the end of this program. Be online. The second topic of today's session is on GIS skills for developing new maps and startups, and it's going to be delivered by Dr. Pinnan Chinnasamy, Assistant Professor, IIT Bombay, Director, Rural Data Research and Analysis, Rudra Labs. The speaker will be joining in another 10 minutes. Please be online.
Kanmani sir has joined. Welcome, sir.
Sir, good morning, sir. Pennan, sir.
Sir, can you hear us? Kanmani, you have to include him, I think. Have you included him in the
Yes, ma'am. 1 minute, ma'am.
presenters list? You have to include him. Kanmani or Kannadasan, please include sir as a presenter.
Ma'am, we have sent the request to join to the sir, ma'am. Just a minute, ma'am.
Maybe you can contact him through phone.
Yes, ma'am, we are contacting him.
என்ன மெயில் ஐடி காமிக்குது?
Fernand sir, kindly rejoin again sir. We have given access as a presenter sir.
Kanmani, could you contact sir? Did you contact sir? Kannadasan, Kanmani?
Yes, ma'am. Yes, ma'am. We are contacting him, ma'am.
Am I audible?
Yes, sir. How are you?
Yes, sir.
Good morning. Looks like my IIT login is not showing us participants, but that's fine. Can I start now?
Welcome, sir.
Thanks a lot. Thanks a lot for having me.
How are you?
Good, madam. How are you? How was everything?
Fine, fine. Okay, shall we start?
Shall we start, ma'am?
Yeah.
Yes, ma'am.
Yes.
We'll start.
The second topic of today's session is on GIS skills for developing new maps and startups, and it's going to be delivered by Dr. Pennan Chinnasamy sir, Assistant Professor, IIT Bombay, Director, Rural Data Research and Analysis, Rudra Labs. Now I request Mr. Kannadasan sir to introduce the speaker.
Good morning. Good morning, sir.
Good morning.
So,
Dr.
sir, thank you, sir. Dr. Pennan Chinnaswamy obtained his master's degree in physics from Wesleyan University, Connecticut, United States of America, followed by a doctoral degree with focus on hydrology from University of Missouri, USA. After his research fellow position with Ashoka Trust for research in ecology and the environment. He joined the International Water Management Institute as a researcher based on geohydrology and remote sensing, and was stationed in Nepal and Indian offices, where he focused on climate change impact on underdeveloped and developing nations. He joined Nanyang Technology University, Singapore as a senior researcher developing real-time flood predicting models for Singapore. He is currently an assistant professor in Indian Institute of Technology, Bombay, India, under the Center for Technology Alternatives for Rural Area, Sitara Department, where his works primarily focusing on natural resources management, natural resource assessment, monitoring and management in rural regions. He is the founding director of the Rural Data Research and Analysis Rudra Lab, which is the first big data lab for rural regions housed in an academic institution in India. He is also an associate faculty with the Interdisciplinary Climate Program on Policy Study Centers in IIT Bombay and a visiting professor with the University of Oulu, Finland. Over the past decades, Pennan has experience working in NGOs, national and regional government agencies and academic institutions, focusing on sustainable surface and groundwater management plans, climate change impacts, large data analysis, and hydrological simulation modelings, and so on. His works has been recognized in many internationally peer-reviewed journals, policy making, policy briefs, and government reports like EPA, NEA, Nepal, World Bank, Asian Development Bank also, and are being used to formulate scientifically validate the best management plans. Those are the credentials. Thank you, sir.
A warm welcome to this program, sir.
Thanks a lot for having me. Thanks a lot. Can I start?
Yes, sir. Yes, sir.
That was a kind introduction, so thanks a lot for the introduction, and thank you for having me. Let me see if I can share my screen. Window 30 seconds. Yeah, is my screen visible?
Yes, sir.
Okay. How long do I have, Dr. Kanmani?
Sir, you take your time, sir.
Okay, so I was asked 1.5 hours, but I think I'll finish because I have another meeting at 1. So I'll finish around
Okay.
1 to 3 minutes. Okay.
Okay, sir. Okay, sir. Okay.
I'll turn off my video just in case. Is my video also showing? Just turn it off for the bandwidth. Okay.
Okay.
What will be here? Okay. So
Sir, kindly make it full screen, sir.
yeah. I'll start now. Good morning, everyone, and thanks a lot for having me here to discuss about GIS skills for developing new maps and startups. So this startup ecosystem is booming in India, and we would be looking at how GIS skills, entrepreneur skills can make you start your own company and where you could associate this work with. Okay, so let's look at the brief outline. We have, I'll just quickly explain GIS, what and why is it necessary. A very, I would say, a very crash course of just 10 minutes or something. And then we'll go into making you think on where to apply GIS and be creative. So GIS is a very creative tool. You could, like for example, it's like a painting where you can put your own colors, you can put your own maps and layers to suit the best application. Okay, so there is no end for it, and you could. So that's why different people can differently think a solution, and you can propose an application. I'll also look at some data that you could start for GIS, because when a startup, you're doing a startup, the big thing with these kind of data analysis is getting the data. And if the data is very expensive, you would end up losing a lot of money, because the solution is cheap, but the data that goes into a solution is very expensive. So you don't make money or you don't make a solution. So we'll go to some open source tools for GIS, data access and databases where you can get some data, good data for these problem statements. Cloud computing, I will just introduce Google Earth very quickly, which is free to use, and a lot of people are making money out of Google. Okay, so it's like Google is making money is fine, but a lot of people use Google to make money themselves, and Google doesn't stop this, and it is open. Anyone can use it. And it is your smartness and creativity how you want to make these entrepreneurs. Okay, for example, Google Map. Google Map is free. You can use it. I can use it. But Ola and Uber thought of connecting people using maps with the drivers and stuff. So that is their entrepreneur idea. So when Ola was housed in IIT Bombay, where I am, and Flipkart example, all these gives better idea of how they used a free open source system to their benefits. Okay, and Google, they don't have to pay Google. Maybe for higher applications, yeah, finer resolutions of maps they pay Google, but just the basics is enough. An entrepreneur, we could look at a very big case example of Map My India, which is a $1 billion company. I just have some connections with them, so I get to know a lot about Map My India as a company. And you could also make small companies. They started very small and very young, at like how you are attending, all of you. So you could look at that angle. And then some GIS skills. Kasim here, who is working with me on these lines. So I do acknowledge that. We are trying to see how we could promote entrepreneurs using GIS and satellite solutions. And we just recently won a big award from DST. So on the same lines, to build capacity for this GIS. So before you even start as a map entrepreneur, you need to know how you could use these data and GIS. So for that, we'll be looking at some of the very important collaborations with industry and government, where they are, how you can collaborate, etc. Uh, so what is GIS? GIS is the Geographic Information System in full form. And it is a software-based solution where you collect, manage, analyze, and model data. Most importantly, not any data, it has to be a spatial data. Okay, so the collecting and analyzing is very hard for spatial data, because initially it was done by maps, hand drawings and cartographs, etc. But that cannot be applied into analyzing and managing, because it was just paper maps. And that is where GIS was such a smart software, where it converted everything digitally and then put everything on one layer so that you could do these analysis and calculations. It allows you to overlay data sets and query them. So basically, you could add as many layers as you want. It's like making a cake. If you want one layer, you can just have one layer of cake, but if you have multiple layers, the taste is different. So similarly, your creativity can be applied on how many layers you put, how complex you want to make the map, and from there you can extract queries. Okay. So let's just take, again, as I said, I'll just spend 10 minutes max on this introduction of GIS. Database are not easy to interpret. And given the data boom, like everyone's talking about data, big data, and then you have AI and ML, all related with data and big data, it is not easy to interpret. Okay, and
Sir,
there's no.
sorry for the interruption, sir. Sir, can you make the screen full, sir?
It is full. Is it not full?
No, sir. Still, it's showing in the first slide alone, sir. Yes. Full screen, sir.
If I put full screen and it's moving, it's not moving, is it? Is it moving now?
No, sir, it's not moving. Now it's in slide 2, sir. Outline.
Oh, okay. Let me see what I should do. I don't know.
F5, sir. Press F5.
No, when I press it, it's not coming. So let me see if I should share as a window rather than. Can you see my screen? Is it visible?
Yes,
now is it moving? Now
yes,
is
sir.
it moving?
Yes, sir. Now it's in full screen, sir.
And is it moving? Can you see
yes,
the new? Can you see slide 3 now? What is GIS?
Yes, sir. Right.
Okay, good.
Okay,
so as I said, it is about collecting and analyzing the data. And I'll share this presentation to all of you so that you could also look at the definitions. It allows you to overlay the data sets. Okay. So here is the data. And as I said, in the big data regime and boom, there's a lot of data collected. There's no scarcity or dearth of data, but how do you keep it? How do you keep it, analyze it, and make these connections is very, very limited. So it is very important for us to convert it into a spatial entity so that you can make some meaning out of the data. So here you see a data set of states, and let's look at some of the attributes. It has the state name, it has population, household, male, female, demographics, white, black, etc. I'm using case studies from the US because these models were made in the US, and so it's easier to quickly understand it. So what you see here is, if you plot it on a map, what happens is you have different of areas which are highlighted. Okay, so while it was a table, you cannot see what is the relationships, what is the correlations, you cannot see. But when you do a map, then you can see some signatures coming out. For example, I just plotted the population. And you could see that US is not fully populated everywhere. It is populated in pockets. So you have this pocket which is highly populated. I don't know if you can you see my pointer? Is it visible? So this excuse me. This population is very highly populated. Along the coast, it's populated, and along the water bodies, it is populated. So these kind of visualizations are worth 1,000 words, as they say. Gives you better insights on how to collect next data. So if I have this, what would I collect? I can collect the bigger airports. I can collect the bigger industries, why these people are there, and what kind of jobs they do. Here it's mostly agriculture, but here it is more industries, banks, those kind of things. Here it is software, right? So this is very important to understand in a GIS platform, that this visualization gives you that tool to look at how you could make these differences in population, and also study in depth the spatial and data correlations. So GIS is a function of both your attributes, which is your data, the spatial data given in columns and rows, which is attribute, and a space which is linked to the data. For example, you have these as a table, like an Excel table. This is your roll number 1, 2, 3, 4, 5, and zone, and then there's a zip code or like the pin code. Okay, what you see here is if just look at the table, you cannot make much sense how they are placed, where they are placed. Zone 2 and 3 need not be attached to each other or close to each other. They could be in a different location. But when you have the spatial function, you have better idea of how the size is, how they are related to each other. Is there a road next to each other, etc., or a big wall like the Great Wall of China, or the border between US and Mexico, they have a wall. So all these are more represented if you have a spatial information, and this spatial information is tied to your data set using GIS. So this is where GIS is. It's not like very rocket science. You have one table and you have another map data separately. What GIS does is it merges both these data sets into one, and that is your GIS data with your location with the table. Okay, so now you have multiple data sets that can have a spatial correlation. It can also allow you to combine data from many other sources, like you have sources in terms of wastewater, land use, transportation, all from the same GIS database. You can combine all of them to make a good map. Okay, so each one can exist as its own map. For example, the police points, the fire points can be their own maps. But to make a more robust and a very informative map, you can have all these data coming into one layer. Okay, so this is your output, which you see in the center, which is a function of all these other data sets. So let's look at the key function of GIS. Data can be positioned by its known spatial coordinates. Every data has a coordinate. Okay, so let's say I, as a person, I have all my data, Aadhaar card, my PAN card, etc. So that is data. But what is my spatial coordinate? Now I'm sitting in Mumbai. So that is my spatial coordinate. I'm a citizen of India. I have a passport. I can go across India. But when you want to make these schemes, or you want to understand where these IITs are, for example, then a map will help, right? So that is the positioning. GIS location is very important. Input and organized generally in layers. You have data coming in layers, and the layers can be combined together as one layer for more better storage and retrieval of information. GI is information, not data. Okay, so here you're converting the data into information. Analyze using relational database management systems, DBMS. Okay, so it has already an inbuilt database management system which can be used for analyzing. And you can always modify, display, make it colorful. As I said, the maps are your creativity. If you look at Garmin and other GPS maps that you have during your car driving, they will have better information of petrol stations, hotels, restaurants on the way. Okay, Google Map has everything, but these maps will have more specifics on this, the road condition, etc. So which will help you to think, okay, should I go in this road or another road if you have a brand new car, for example. So let's look at quickly the GIS process. You would define a problem. Okay, so my problem is, for example, I want to map the best route between Chennai and Mumbai. Okay, that is my problem. I define the problem. Then you collect the criteria for GIS assessment. So I have the problem statement, but what is the GIS part of it, which is the map. I'm going to map the route. I'm going to map the best route. Okay, and the best route can be as time, or the best smooth ride I want. Okay, so the quickest way is to go through a village and come out, but the road is so bad and you'd actually go slower. Okay, so but if you want a good ride, you define the GIS. Then you import your data sets. You build a good robust data set, which then gives you the ability to and then you get the output. Okay, so now you define the problem, you got the output. But do you stop here? Is this an entrepreneur? No, because right now it's just a scientific problem. You stop. What an entrepreneur does, and what a more higher advanced scientist would do is, a researcher would do is, they will use it for a decision. Okay, I made these maps, but how can I make it as a decision tool? How can I give it as a better information? In this age, data is packed as information and given to you for cost. Okay, so for example, your weather advisories, your weather channels you see, a channel is there. All it does is takes its data and then packages it at, okay, in 1 hour you're going to get rainfall, 2 hours there will be flooding, those kind of advisories. So those are decisions which are taken from your output and given to you as a model. You don't stop here. Okay, so the dotted lines shows that after you arrive at that decision, you still continue to refine the problem, not define the same problem, but refine, reword the problem, make it more robust, and then go across this cycle again. Okay, if you continue the cycle again and again, you will be growing up in your entrepreneur skills. If you stop, then it is just one problem you addressed, you gave the output, and then you move on to the next problem. So this is how GIS is done in entrepreneur scale. And let's look at some of the applications so that you can start thinking of where you could have an entrepreneur style pathway or careers. Mapping and visualization is the key. It is the start. Okay, you map and you show data in different visual styles. For example, the COVID, when you show a graph, okay, a graph is shown, it doesn't make much sense. But when you show hotspots, like an India map, and there is bubbles where the COVID is high, then the government knows, okay, I should not be sending my resources to one location where, yes, COVID is there, but it's not a big COVID. So you send it to different locations. And then you can see what is the connection between the COVID locations. Your transport analysis, the best routes for not only for traveling, but also your agricultural produce, medicine, whatever it is, all needs to travel, right? So transport is a big analysis in spatial criteria. Environmental impact assessments are really big. For example, when industries are developing, when air quality is decreasing, when you have climate change impacts, what is the impact on environment? For example, your rivers, lakes, or your forest, how are they degrading? How are they managing? Hotspot analysis for accidents. Hotspot can be for anything: dengue break, COVID break, accidents, etc. Rural and urban planning needs a lot of these GIS maps, where you collect data on the infrastructure and are they good or not, and how you make roads, how you make schools, locations, etc. Disaster management, floods, droughts, fire, those kind of disaster. Where do you put your evacuation? Okay, so when Chennai was flooded recently, where do you put your people? Where do you house them until the water level comes down? Is a question. Okay, and it is not just only the schools. Always it is the government schools they put. But right now they also have a GIS wing for disaster management, which will quickly tell them where there is less water. It could be even a private school. It can be a hotel. Because all this should be open for disaster management when a disaster strikes. So quickly they can put more people and save more lives. Navigation, flights, ships, planes, etc. Drones are guided by GIS. Okay, even though they have their own cameras and flying, it is very important to give a map for it to be guided. It cannot just drive by itself. Surveying, when you do census survey and other governance from the government of India or any other government planning, you need the GIS tools. I'll get into specific examples to give you some information on what you can use. Okay, a taxpayer's office. So the commissioner of taxes would use this GIS layers to see what is the difference between the size of your occupancy. Okay, so there are encroachments in every city. You could see a lot of encroachments happening, or the land is being abused by building encroaching into the road, or you're taking the water bodies, etc., the kuam on the banks, those kind of things. So all these can be mapped and studied by a taxpayer's office, and they can actually put more tax if you are claiming 10 acres of land, but you have 15 acres of land, for example. Okay, so all this could be mapped and then given back to the user for better tax. An engineering department monitors the condition of roads. So you have roads, but these are not one-time data. You can collect data multiple times. You can collect GIS multiple times and then improve the road condition. Okay. A police department uses crime to study the crime patterns. For example, you have a location. This is your location map, okay, GIS. When you put all these data of crimes, where it is happening, how far it is happening, then a pattern starts to emerge, a trend starts to emerge. And then suddenly the police can go there and capture the defendants, or they could put more rules and regulations there. For example, in the T Nagar shopping area, you would see a lot of dummy police booths. Okay, just the police station booth would be there, but police won't be there sometimes, because just having that and a light going on the top makes people, the thieves actually, to be cautious. Okay, excuse me. And those are strategically placed based on these maps. And wherever the crimes happen a lot, like beach, those kind of things. Wastewater department prioritizes areas for repair after an earthquake, or where to put the new pipelines, etc., are planned using GIS. You have an overlay map, and then inside you have a layer map which can have just the pipelines. It is a 3D model. Okay, GIS can be effectively used as a 3D. It is not only above the ground; it can be below the ground. All it needs is data and a location for it. Okay, so for example, in this location where I am sitting, it is one GPS location. Okay, 1 lat long, and that 1 lat long can be applied to all the 4 floors we are sitting in. Okay, it is vertically only one point. So GIS can capture saying that Penan is sitting in second floor at this lat long. Above him, there is X professor sitting in Y floor, same lat long. Okay, so that 3D visualization can be done. If I move 10 meters away, my XY will change, the lat long will change, and the elevation can also change. Telecommunication, we are doing a project with the telecommunication department to see how the internet is available for people. Okay, so these red dots you see are the location of your towers. Having the tower itself doesn't mean you get good internet. Okay, especially now in COVID, where children cannot access good information, good internet power to take classes. So what do? They go to high elevations or go up in the hills to take good tower signal. So you can see here, this is the center of the tower, but the signal strength is only on one side. Maybe a tree or maybe a big mountain hill slope is preventing the signal to go the other side. And more importantly, you have these small dots. Network coverage, and that could be because of multiple reasons. However, this map is very important to tell, like, okay, if you place a good school for COVID scenario, you can place it in between so that you have good internet on both sides. But if you place it here, even you put 1,000 crores or whatever for the school, I'm saying, if there's no internet, what is the use of it, right? So all or a good connecting signal, etc. So that is where these GIS can help. And as a hydrologist, I am by training. It helps in a lot of water quality monitoring, how the water quality changes between sites, etc. If you have just numbers, it doesn't make sense. But if you put it as a visualization, then you say, oh, there is a water movement. It is moving towards one side because of some disturbance. That part you can see. A couple of more examples I'll give. A pipeline company would know where to put your pipes for better, supply of water. And a biologist can study the impact of development on watersheds or plants, animals, species. All these Even biologists use it. So GIS is a very beautiful tool. Medical professionals can use it. Biologists, space technologies, lawyers, police, every single person can use it based on their need. Okay, so for example, a biologist, they will put all these important species, mapping the species in the city or the country. For example, in Chennai, when I was a kid, I used to see these sparrows, the small birds. Right now, we don't have them. Okay, and I'm searching for a map to show where are these birds. And only when you go to villages, you see these small birds in a very remote location. So at least now, if I have a map, they can be protected. Okay, we can make sure that some things are done to keep those birds and animals alive. So electricity bill, as I said, your electricity utility will know where to put your electricity meters, where to prevent electricity theft, for example, where the connection is weak. All these can be mapped, and violators can be quickly assessed. And most importantly, the meteorologist, where they give flood warning for crops, or severe storm warnings for cities. For example, Chennai, we need these maps. Why? Because we have the metro, and if it is flooding and the metro under the tunnel and everywhere you get water, then the whole plan cannot work. The metro has to be shut down. Okay, and cleaning and removing it is really expensive. So moving on, it can also be used to create business locations, and this is what Amazon is doing. They create these maps to show where are the hotspots for a business. Swiggy, Zomato, all these are using GIS. They will say that, okay, you can open, for example, a Kerala restaurant in this block, because a lot of these people want Kerala Malayalam food, like chicken or whatever it is. Okay, and Chinese, for example, this block. So all this, even if you have data as a table, it doesn't make sense unless you put it in a GIS database. A police dispatcher finds the easiest route to emergency. As I said, routing is one cost in GIS, but how do you use it? How do you use it as an application can differ. You can just blatantly say, no, I just want one point to one point A to B, I want to go, and I need a map. That is simple GIS. But if you want to use it during a police emergency, an ambulance emergency, this is the map you need to use. Because police and ambulance can go through the other ways to get to the point quickly. They are allowed to go, right? Because on a case they can go even in the wrong way, but they have to catch the case. So in those extreme situations, the police will have different GIS maps. And then firefighting, same thing. When emergency comes, you can they can quickly go and assess the fire. And then water resource managers, tracers, etc. Basically, hydrologists use a lot to look at how the water is supplied. So here comes the bigger part. Okay, and a lot of these slides were made for the US system, but in recent times, the Indian government is opening also applications in the defense. Right, the news is already out. So GIS has tremendous applications in the protection scenario. For example, let's say site selection for helicopter landings. Okay, it is very important to know where I could land my helicopters, and based on the landing, you have a different model of helicopter you need to build. Amphibious assault, water inside the water, outside the water, it goes both land and water kind of combat. Where do you park these high utility machines, war machines? The buffer zones, where do you create a buffer zone for army? How thick it should be to prevent their exercise from being seen from the outside world. Flight planning, drone planning. Now you have a lot of these drones going in for surveillance. US uses drones for even assault, right? So they carry weapons and battlefield visualization. So you can make a 3D map using GIS and create these visualizations before going to the battle. Okay, and these are already done by your high-end GIS networks, etc. For example, Dassault, which makes the Rafaels, etc., has also that GIS wing. Okay, they have a Dassault GIS wing which looks at these very high critical maps GIS maps they could use for intelligence. They call army intelligence, warfare intelligence, etc. For us, it is more protection. You're not going for war, but you have to prevent others from intruding, and you have to make sure your borders are secure. Okay, so it is more of security rather than war. I have to tell this because currently there's a war scenario going on in the world, right? So the other thing is, excuse me, real-time applications. This is very important in GIS. You have all these data, but unless it is put as a visualization map, it is very, very hard to assess where you want to do these rescue activities. Let's take the example of the Kerala floods in 2018. Okay, we have this map. Okay, this is the map before the flood. Everyone has this map, so it's not a problem. But suddenly, when the big flood happens, we need a map and put in a dashboard, GIS dashboard, to see where the locations are specifically flooded, so that I can send people and capture them. If those who are in Kerala would understand, this have less road connectivity. Actually, they have boats to go from one house to the other house. Okay, so it is a very a different scenario which needs high GIS mapping to look at the flood levels and save these people from these floods. Okay, and also to manage this land better to prevent these kind of floods from happening. So when this floods happened, what did we do? We had the data, but we didn't have the expertise to make these GIS maps and give it to the government at once. Rather, we waited for NASA and MIT to give these maps. I'll just show you how it looks like really quick. Okay. So for example, I'm just clicking this link. I'll give the link in the talk also, so you can also look at the project yourself. Is my screen visible? Yes, no. Am I audible?
Yes, sir. Slides not visible, sir.
Okay. So let me see if I should reshare again.
Yes, sir.
Is my screen visible, Dr. Kanadasan? Or Mr. Is it visible?
Yes, sir. Yes, sir.
Okay, so you see here, all they did is a GIS map and some sliding tools that can help your land managers or people who want to do these evacuations quickly look at it. And this was done in Earth Observatory, NASA, MIT for India. Okay, so that is the point I'm trying to tell you, that if we build this entrepreneurs, if we build these companies in India, then the government would readily come and ask you to help you in these kind of situations. And these situations are going to happen a lot in at least these vulnerable regions because of climate change. So quickly see, this is the before the flood, just a couple of days, not 10 years ago, 20 years ago. Okay, so let's say this is August. I think it was August. Yeah, February 6th and August 22. August 22 was the floods, and February 6th they take. Okay, and when I slide the slider, you could see that a lot of water is in the central region, covering the central region. And now I know where to go and save the people, because all these houses are now drowned. Okay? All these houses. It was 100-year flood. It was a very bad flood in Kerala. Okay, and this map, just a GIS-based remote sensing map, could have saved a lot of lives. Okay, so this is what we need to look at in detail, and why other countries can quickly do it, whereas we are struggling to do it. That aspect we need to study. Okay, let me reshare my screen. Yeah, I've given the link, so feel free to look at the link and make these kind of maps, and tutorials can be made. You can teach, so there can be an entrepreneur for teaching these GIS skills for students, making them self-sufficient in making these maps, etc. Let's look at some tools for GIS mapping. So processing of large data sets cannot be done just simply without a software, and that is where GIS comes in. And this side, all you see is multiple data sets from all open source and pay source images. For example, your open source data would be Sentinel-1, 2, Landsats. Commercial data would be Worldwide, GeoEye. So these Worldwide and GeoEyes are pay per use. So you have to tell them that I want the image of Kerala, for example. Then they will park the satellite there and they'll take the image and send it to you for a big cost. There's a cost, but it is useful, and that is why they are surviving, right? Whirlwind and GeoEye. Then you have your aerial imagery, drones, planes. So all these small commercial planes, they can also have a camera on the bottom and collect images. Okay, so think about your phones; they can collect images for GIS. So it's the same thing, and other raster data. So all of this can be combined, and you need a working platform and tool to make these maps for an entrepreneur scale. Okay. Sorry, I'm in a class. I'll call you back. So what happens is you have cloud GIS. You can store the data in clouds. You can store the data in web applications, etc. And you can also have open source GIS maps, which is what we are trying to promote, because ArcGIS is a commercial application, commercial GIS, but it's expensive. And when you want to sell a technology, sometimes the government will not be able to pay for the software. But if you want to observe the cost, say, okay, sir, you just pay for the service, I will pay for the software, then you can use pay softwares, because pay softwares has their own benefits. It's easier or something, but QGIS is doing a lot nowadays. For example, even satellites are launched in Europe using QGIS, which is an open source software, which means they pick the location for the satellite launch, the rocket launches, etc. And they also use the GIS maps for saying where to position the satellite, how to monitor the satellite, those kind of things. So yes, both open source and freeware is there, open source QGIS, and you have all the other software that is also accepted worldwide. I'll just quickly introduce QGIS for those who don't know. So this is how the interface looks like, and there's a lot of bullets on the top, a lot of tools on the top that are used. Most importantly, you see here as plugins. Okay, so this plugins is where QGIS stands out from ArcGIS, from the commercial softwares. Because in plugins, that can be contributed by anyone. I can contribute to a tool, you can contribute to a tool. So this can be an entrepreneur path by its own. For example, if you are very good in medical data and medical mapping, and you give plugins, you could tell the government that if you want to do outbreak, dengue outbreak or other outbreak analysis, COVID outbreak, you could use my plugin, but you have to pay for the plugin, because entrepreneur means you're doing it for a cost. You want to survive your company, you want to take a salary, etc. If it is volunteers or like me for research and organization, we just do it for free, because that is our role as a IIT. We have to do research and volunteering work. But for an entrepreneur, it's different. You have to sell the product. So plugins is where you can sell it, whereas in commercial software, it takes time for your product to go to their shelf and then you sell it. Okay, it's like you have Amazon, where initially Amazon was only selling their own products. Then they said, oh, only the good products I would keep on my Amazon website and sell. But now anyone can sell on Amazon, right? Anything you write can be a book for a publisher. You can do a small handicraft at home, and you can be very specialized in it. Maybe you're doing a handicraft using matches. Now you can become an entrepreneur because you have Amazon, which can just host it on the site, and Amazon will only charge you if it sells. Okay, because they have so much a robust system. To add one more product on their catalog doesn't cost them anything. So what they'll say, I will not charge you anything. Just give me your product, give me images of your product. I'll put it on my Amazon website. And then when it sells, you give me 20%. Okay, whatever you sell, 20% comes to me. Something like that. So like that, plugins can work. And QGIS is where you can make these plugins. You can host it for free in QGIS software. It is free. And those who read about it can use it, can pay for you if they want it. You can give them 10% free software so that they can try it, and if they like it, they come back to you and ask for more. It is like Google services. Google gives you all the searches, Google gives you all the maps. But if you want a high-end map, like Ola and Uber use, for example, they will pay for Google to give a very sophisticated map. It has a lot of data, features, which a normal map doesn't have. All this can be included. For example, your Swiggy maps and Zomato maps, it is different from your Google map. It doesn't capture the house cooking people, like home food delivery guys. But Zomato, that is the business, right? So they will connect, put that on the map, and put it on their website. So when you buy it, you buy that service. So this is where you could add, plug in as a entrepreneur, and then make money out of it when it sells. You could also make it in QGIS for free, and then promote it in QGIS forums and other places where you could actually get it accepted, but at a slower pace also. Okay, the basics of map making are just good frames, neat borders, coloring, labels, legends. I think these are just a very basic way of to show what a map needs, and a good way to sell your maps. All these are very important to house in your map. A good border, a good coloring, appeasing coloring. For example, water should be blue. If you color water red and say, here's a flood inundation map, they will be thinking, why is water red? Or maybe red is danger. So those kind of creativities you should have. Legends, what is the map explaining? What does the color mean? What does the number mean? Has to be given. North arrow to give orientation, scale, etc., etc. All of this is needed. So map making is part of GIS entrepreneurs. It is a very, very key part. So make sure you have the basics right. I cannot change. Okay, source and credits. Always give the source and credits for the map. It shows that you have class to accept who has given the data rather than you claiming all the data is yours. For example, this kind of a map. It is for India. I show Tamil Nadu. I show the different districts in Tamil Nadu. I have a scale. I have the north arrow, etc. So it's just the basics of map making, and make sure it is appeasing. Now coming to the data and data sources. Okay, as I said, building skills on mapping is necessary, but for a problem statement, do you have the data is necessary? Okay, if you ask me, the big insects was kind of trying to invade India during the COVID. If you had looked at the maps and news, it was very bad. Like it was eating all the agricultural crops in the northern India. And if we had not contained it, it could have come to South India also. I think it came up to Karnataka. So, do we have the data for the grasshoppers, which is the locust? No, we didn't. So, if you can make these GIS maps, you can say, okay, I'm going to make a map. I'm going to give you the government a map to contain these pests. But if you don't have the data, then you cannot make the maps. It is the same zero level again, TR level you say in your entrepreneurs. So where can we get these kind of data? I'll just share with you some free and open remote sensing data, GIS data that you can get for free. And the first are all these missions. Okay, so Earth satellite missions are tremendously increasing. Just a couple of days ago, I think on February 14, Valentine's Day, India launched a lot of satellites, 6 o'clock in the morning. So it was a success. And then on the other hand, you have private players also jumping in on the space network. So all these satellites are there. And to get satellites on the top, it has to have some civilian use. Civilian means public use for people, etc. And for that, you are in need to have good maps, good map making skills, and understand how to download the data, where to get the data, etc. So let's look at quickly some of these missions. Okay, so you have Tempo, for example, temperature, Grace for groundwater, Sentinel for land use, land cover, and then Tropics for rainfall, and then INSAR for soil moisture, etc. SMAP for soil moisture. So you can see how different satellites are used to monitor the Earth, and based on that, you can make a product out of the satellite data. And for that, you can use GIS. Drones are also there, but drones are expensive to fly. Here, you don't have to pay anything for the data. You just download the data for free. These are based on these international rules and policies. And they are not the only one. So what I showed initially was the NASA. I'll get back to these NASA links and other things. You have the European stations also, where it is divided as meteorological data, Copernicus or Sentinel missions, where it just takes images of know how big the building is. On paper, when you ask for taxes, maybe you say, I'm going to build 1,000 square feet. Okay, but in reality, because no one is going to come and measure after you build always, right? So, or after the first measurement, you can still push your boundary, and you take 1,200 square feet, for example, and you'll be paying lower tax. The government is at loss. So now you can make an app, you can make a GIS platform where it quickly updates you the tax office when there is a change, and gives an area estimate. Okay, an area estimate 1,000 square feet. It is in an urban setting, so the urban rate for land tax is this, and it gives you the tax number, the tax how much you have to pay, and that can be given as a product or a tool to the taxpayer's office. And now that the tax commissioner is very happy to quickly do these tax estimations. I knew some of the tax commissioners are now trained in drone technology also, because they have to quickly fly the drones to see the how much land is, how much the construction is, and are they getting the correct taxes or not. It's not like your bank account where you can change and then not collect data. Right? The last is your Earth Explorer, where it takes specifics of the Earth, water, soil moisture, those kind of things. I'll come back to this in detail permission soon. And we are not far away. So I showed the NASA, I showed the ESA. Indian satellites are coming up. So we are ranked really high in space technology. And if we are not developing in space, we are not called a developed nation. So it is very important for India to continue pushing the satellites, pushing the rocket missions to compete with other countries as a developed nation. See, when you make these programs big, then they come to us for business. Okay, so India is doing the same thing. You do multiple launches very effectively and very cost effectively. Then the countries like Philippines, Indonesia, they'll come and say, please launch our satellites, and then we can launch it as a cost, as a business, and that is what is happening in India right now. And we are selling now these military things to Indonesia, Philippines, etc. So all this requires a lot of good GIS understanding and entrepreneurs who are supporting the GIS initiative. So let's take a look at the key players. At least for you, it will be the Indian Space Research Organization, or ISRO. Excuse me. So you have MOSDAQ, which is a good website for getting data on weather particulars, and telling maps on you can make a product out of it. You can sell it for an insurance company, for example, on getting them prepared for flood insurance. Flood insurance is the money they pay for the farmers, etc. Right? So if you can get those data and then work on these entrepreneur tracks, you can actually build good insurance models. And right now, you also have space-based observation of natural resources like wetlands, forests, and also these land use, land cover, species, etc. So ISRO is also pumping a lot of resources on protecting the natural environment. Understand that India is also guided by foreign or international treaties like the IPCC, where we have to show that we are curbing the carbon. We are doing some things to prevent climate change from happening. And for that, natural resource management is key, and these satellites can help. and these data are free. So it's up to you to use it wisely for a particular cause or not. For example, this is the rain-induced flood simulations that you see for a particular region, and you could see that in Kerala how the flood increases, how the flood volume is changing. All are based on satellite imagery and GIS mapping. You see how the color is changing, how the volume of water, and now the government can quickly go and say you should not be building houses there, or you should increase the insurance of the houses in this area, because my GIS maps show that it is vulnerable for floods. All these can be seen and learned how to download the data, how you get the data, etc., from YouTube channels. So this is a YouTube ISRO product. You could go there and see how you could download the data, how you could convert the data, Mosdac for sure, into multiple platforms. FOSSEE, where I'm also working as a co-PI, also has a lot of good GIS tutorials in different languages, and you could use that for starting your startup, okay, your entrepreneurs. So learning, don't say I don't know, and that is one thing I'm seeing when I'm sitting on the board of startups. When I'm asked to review startups, they don't know the GIS technology, but they want to do the maps. For example, they'll come and say, "No, sir, I want to provide a dashboard, an app that would capture, flood inundations for Kerala." Then I ask about the GIS, they don't know. Then I ask about the satellite data, they don't know. The idea is there, but how to get to that idea, you should be clear. So when you pitch all this, you need to make sure that you understand the data, you get updated on the data available, the free data, and then do it. Because most of this data was initially costly. Okay, so initially you had to pay ISRO data, etc. But now they're making it open source, so anyone can use it. Let's look at the NASA, the National Aeronautics and Space Administration toys, I would call them. They have multiple satellites. All the dots you see are satellites. Okay, and they rank number one along with China in the number of space missions, the number of successful satellites orbiting the galaxy. It is not only our planet. They have thrown in a lot of telescopes, etc., and all of these can be used for maps. Okay, so in the Earth, it is the most. You have all these different satellites, especially Landsat, as I said, takes images of the land at a very high resolution. Landsat 9 is recently up, Sentinel 6, GRACE for groundwater, Aqua for water bodies, lakes, etc. For example, if you say the dam level in Tamil Nadu, we can easily get the dam level, but the volume, the spread of the area is very hard. Okay, even the officials won't know how big the area is changing, because you need an aerial imagery. And if you could make a map to quickly tell the volume based on the area and the height of the dam, then you could easily tell the resource person, this is the volume, this is how much you can release for irrigation, or you want to save the water, this is how much you have. Now the dam authorities can put a good rate on the water they supply for farmers or industries. Industries, when they use this water, they have to pay a good fees. So there's multiple satellites, and even for Sun, even for the different planets like Saturn, Jupiter, Mercury, Mars. There's a lot of mission on Mars, so they're looking at it, and the Moon. Okay, even they're trying to set up houses or communities in the Moon. So you can do a GIS layer for the Moon. The data is available for free. Okay, so think about these things. Again, if you think creatively, then you get more and more ideas. Moving on, I would focus more on the satellites and the GIS technology. If we can still live on the Earth, why not? Okay, I'm not sure we have enough attractions in Mars to go to Mars. I don't know, but I'm okay with my Earth. So just look at these different satellites and how they can capture the data. You can mix and match these satellites. Okay, which means you're free in GIS environment. That is what GIS does. You can take one satellite from, it's like a shopping cart. You can go take one satellite take one satellite from NASA, take one satellite from ESA, European Space Agency, and take one from ISRO, and you can make a product out of it. Here, what you see is the planet as Grace sees it. You can see it is not a smooth surface. It is bumpy, it has different elevations, and most importantly, it is not a good orange ball that you always assume a globe is. It is distorted. The shape is kind of squished on some angles, but it is a beautiful planet. So, and the only planet that is currently serving so much life forms in our galaxy. So what you could see here is these data can be incorporated with other data as a startup, and you can sell the information, not the data, but the information for the public or the government agencies. You could go to this link to see how you could download data. Any data you could download for a particular cost, and it's very straightforward. You can download it as a raster format or a GIS format. You run it on a GIS environment and you convert it to what information you want. You want to have a map, you can convert it into a map PDF and then print it and give it. Or if you want other resources also, you can check. Moving to the other shopping shop, we have ESA, as I said. They also have a fleet for solar system. Again, let's focus only on the Earth. You have a lot of satellites. Okay, I promote you to use more Indian satellites because of the Indian business scenario, and also the satellites are pretty good in terms of ISRO's mandate. So you can have good satellites, but you can also make a product combining them. For example, if you go to the ISRO links I sent you earlier, you will see the NASA satellite, the Sentinel satellite also there, which is mixed with ISRO satellite. They give it for free, and so that is where you should know how much is available for free as an entrepreneur, and what is the difference that you bring to the business environment. So this is how it works. You get satellite observation data, you acquire the data, archive, which is creating databases, you clean, you use all these different tools or hardware, software to clean the data, make it more, in a unique, short fashion, and storable fashion. And then you do some pre-processing. This is where you make money. Okay, what type of softwares you use to pre-process? What is the value you add to the data? Okay, is it some correction, or is it another data set that you have, only you have, that you can attend? That's where I'm going to come to the current map, my India business model. And then your information, how do you abstract the information? Do you want to do classification, etc.? And then what is the product you're going to give out? Is it a thematic map? Is it a information? Is it a push notification on your SMS? Is it an app-based model? Those kind of things. And the Earth Engine catalog, the Google Earth, has lots of data. Okay? Look at the data per day. It comes 4,000 new images every single day comes into Google Earth Engine, which is free to use. All these satellites pump a lot of data into it. Okay, greater than 5 million images, and it's not our phone image. It's not such a small image. It's big. It covers the entire planet. Okay, entire planet, more than 4,000 new images every single day. It goes above 5 petabytes. Leave gigabytes, leave terabytes. 1,000 terabytes make 1 petabyte. Okay, so 5,000 terabytes of image comes in. You don't have the storage, you don't have the computers to process that data, but don't worry, Google Earth Engine is running behind, and it does it for free because it has connections with these NASA, ESA, etc. They do some processing, and then they combine it with Google Earth Engine and give it for free. Those who have Google account, Gmail account, can easily access these data. FOSSEE tutorials are there, where I am part, IITB is part, and the links are already given for FOSSEE. Just Google FOSSEE tutorials. You'll get all these GIS tutorials for free. So let's now come back to entrepreneur track. Okay, what is the need in the business scenario? What do you need? Okay, that is very important to understand. Lots of data is available. I showed a lot of data. free data, paid data, government data, and then localized data, but less professionals to work on maps and ideas. Okay? Very less GIS professionals. We had to go to MIT to make that flood map for Kerala. So that shows that capacity is less. And then ideas. How do you creatively think of a problem? How do you creatively think as a mapping solution is the point. Okay, a lot of things can be taught and quickly done. For example, I saw a map which is really funny, but it is good in a European situation. Everyone has pets in Europe. Okay, mostly they have dogs and cats. In Finland, where I am working, I'm still currently visiting faculty. I saw a lot of cats and dogs, but they needed a location where they can take them and make them run and play a park. How do we do it in India? We just say, let's go to the beach, or let's go there, let's go here. We just word of mouth, and sometimes it is not correct. It doesn't work that way. But these guys have an app which actually shows you the map of where the location for taking the dogs and running, and the current status of how many dogs are running. Because dogs like to have other dogs to run, okay, and cats would like to play with or fight with other cats, whatever it is. So think about this. Just a small idea, very localized problem, but they see how they use GIS for it. So there are a lot of idea maps available, data available. How do you convert it into ideas? And how do you take a subscription out? Those who are watching these Shark Tank entrepreneurs, just see how many people are taking maps. So many maps are there, so many entrepreneurs are there. I'm sitting here and thinking, wow, these could be done at a dirt cheap cost, very like maybe in lakhs, but they're asking crores and they're getting crores in the show. So I'm not bringing the show name here for other reasons. It is only for the GIS and how they quickly make these maps and money. Okay, and again, the competition is very tough. So you have to quickly make a map, and if you cannot fine tune, you have to stop, make another idea. Okay, the fine tuning can happen only at a particular level. What is your value addition that you put on the map is very important. And please know that the satellite sector, the space sector is being privatized. A lot of GIS applications will be opening now. So it is a good time to invest your time on your entrepreneurs track in GIS. There are multiple companies, so very big competition. However, they only look at the broader scale. The localized problems you can still work on because you have the connections with your panchayat office. You have the connection with your health department. For example, I work with the Tamil Nadu Health Department very closely. I cannot do that for the same in the US because of the distance and the connections, right? So that is where your local positioning can help greatly in making these maps. So don't think that, oh, how can I compete with them? What are they not doing? You can do. It's like you already have a car factory. Okay, you cannot make a car. For example, when you start, you cannot compete with a car factory, but you can make the small nuts and bolts which the car factory definitely needs. Okay, and that is how businesses are made. Entrepreneurs are made like that. You cannot just directly jump into the car market. If you have the bandwidth, you have the money, yes, you can. But that's how people start slowly. Okay? The Indian companies, if you look at Bajaj, Hero Honda, all of them were small. And then they had these when they grew big, they had these collaborations with, for example, Honda with Hero, Maruti with Suzuki, and then they detach themselves as an own company by themselves. So think about it. It is not that you're competing with these big companies. You can still make small, very useful and very widely acceptable maps. Private sectors in space and GIS is not only for US or other countries. India is jumping into it. So this is the recent news. India opens space sector for private companies. So your vendor, your market, it's not only ISRO, but now sooner a lot of private space organizations, private reforms would happen. Okay, this is a very recent news. Gear up. This is the right time. This workshop is happening so that you can plan on setting it up. I would say that if you want to think big, always have tie-up with a government research institute like IITs and others, because we have quicker access to data, and the credibility is already established. So you can start small, and then we have this incubator. I think CIC is also there, so they have incubators. And the data, when you get data, you can get it for easily if you know these contacts. Okay, so and a lot of people are there to incubate your ideas on these. So think about that term. Okay, so opening up Indian space is pretty big. And there are multiple verticals in which your ideas can be used for making creative maps. Think about applications. GIS is about applications, fine-tuning the data. Civilian, military, private agencies, all these things, all these would be interested in you. Civilian means, for example, the IAS collector can come and ask you, can you give me a map of my district boundaries, how it has been encroached, those kind of things. So you're going to be a solution for a collector for civilian aspects. It can be for military. You can have quicker analyzing GIS techniques for rapid information for the boundaries, the borders in Kashmir, and now in this side also China is coming into Nepal borders and all these things, right? So you can have quicker maps that can give the military very high resolution data and good information. They also have the data, they have the satellites, but they don't have the information. So the information you can do it and sell it. For example, a student team from IIT Bombay has won the drone technology with DRDO, and they will be developing drones for military. DRDO is the research wing of the military or the army, the defense. Okay, defense research organization, DRDO. So they would be making these GIS components, GIS maps as a private company, but for DRDO. So that is how you should think about starting these entrepreneur tracks for helping or addressing these critical problems. I think my 1 hour is up, but I'll just finish it off in another 10-15 minutes. Okay, so before I move, any questions, or should we take questions later?
Sir,
At
after
the end of the presentation, we will have the query session, sir.
Okay, fine. Yeah, if any questions, you can still chat on, type it on the chat box. I think Mr. Kasim is there. He'll also take note to make sure I capture it, and you can also tell me later because they might forget. Just make sure the questions, if you have, just let me know it. Okay. So moving on, data collection and databases are plenty. Okay, all you have to do is make sure you collect data in GIS environments, convert them into, if not convert them into GIS environments, clean the data. That is very important. All these satellite data, the observation data that you have to use in GIS has errors. You would need to clean it, and that is where your entrepreneur skills, your company skills can happen. Just look at this map, a PAN database 2018, all records. They're selling it as a DVD. Okay, it's selling. It's Nanjil Databases is a company, sales, leads, etc., etc. So what they do is they're not creating the data. Okay, they're collecting the data, multiple databases, 100 plus crore records. And if, for your information, as I said, if this is 30 GB, you're already getting 5 petabytes of data per day. Okay, per day 5 petabytes, and 30 GB is nothing when you compare to petabytes, right? So, but still, the company was able to make it as a model. I'm going to collect what is information is necessary. The government officials or the private official companies need not have the time for selling these data or making this data. I'm going to convert it as an information, as a DVD or a Google Drive link, and they put it. Even the census data and the boundary data of India, if you go to the GSI, the Geological Survey of India, or the Survey of India department, you would see that you have to download it after you pay for it. For example, the boundary of India, you have to pay 24,000 for one layer, one GIS layer, 24,000. You cannot share it. It's easily shareable, but if you share it, it is criminal offense. So this is how you can take data, add your value to it, and then sell it in the market. Make sure you say that it is a criminal offense to reproduce the data, and that is how all entrepreneur skills work in GIS. or you can make different data protective. Okay, you can protect the data. You can think about that. How can you make data protective? Okay, it is like papers. I can download a paper. I can pay it for one time, but I can still sell it for others. But nowadays the companies are making sure that they put encryption in it. When you download the paper, you can download it one time. You can read it 20 times. After 20 times, if you read it, it just gets deleted by itself. Okay, or they give it 1 month time. 1 month you can read it. After that, it gets deleted by itself. So these kind of things you can look at how you could make data map products and make sure that you cut down on privacy, those piracy, etc., etc. So make databases. Thematic maps are very important. Country-specific solutions are important. Okay, and it is also important to understand different themes. Okay, make sure the themes already exist or not. If it already exists, don't compete, or see how you could be different. For example, the health vertical. If there's already health data, make sure that you're not competing with the health data, but you are making it different. What difference can you bring? Country specific data, same thing. More specific to a particular country. You can make maps for Sri Lanka, our partners, Bhutan, Nepal, where GIS capacity and remote sensing capacity may not be as big. Okay, so what we have here is robust infrastructure, access to these highly credible institutions where they have good computing power, etc. And you can make them collaborations to make these companies. Most importantly, focus on solutions, not data. Okay, data as per se they don't like. Just data. Okay, you're going to give me extra data. Fine, they just throw it away. If you give them information, if you give them advisories, SMS, app notifications, that helps. Okay. For example, when tomato prices are plummeting, tomatoes became very cheap. People are throwing it in the roads and stuff. Then suddenly 2 weeks later, it is 100 rupees per kilo. Okay, so you see how it is different. So how do you quickly connect the farmers to tomato puree or ketchup industry to buy these at a very good price? Both farmers and the ketchup industry is benefiting. So that is GIS. How do you quickly connect what tomato puree is a big business in India. Okay, converting the tomato into juice, puree, and then ketchup. In fact, we are one of the largest exporters of ketchup in the world, and still we are wasting tomatoes, right? So the market is there. How do you connect the market is key. Roads, networks, schools, solutions. Okay, so all think broadly, and then start with the scratch board. What is the problem? Who our stakeholders are? Who are we targeting? Also, you need to be very careful. Making map solutions. I'm going to take Map My India as a case example now. Okay, Map My India is one of the biggest private entities. It is listed as a angel industry, $1 billion dollar industry in India. They give you specific maps. If you just go to the website, all of these are taken from the website, so there's nothing new. You can buy this kind of a very sophisticated GPS for your drive. It knows you. For example, if you are a business professional, okay, if you are a paper industry professional, when you're driving, it will pick up only the paper industries which are suited to you. If I like Chinese food, for example, if I'm driving, the restaurants will come up, but only the Chinese restaurants would be showing in a different color, so I can quickly go to them. When my gas in my petrol in my car is low, then this thing can automatically pick up your gas. So see how this can be very dynamic and help the reader. And this is what is in your costly luxury cars. Your Mercedes and BMWs all have this entity in it, and that is why the price is very expensive. Okay, so think about how you could give this at a very low cost. and that is what Make My India is doing. Map My India. So map data, they give you map data. Okay. 1 second, I think my battery is running low, but let me see if I could. Yeah. Can you see my screen? Is it visible? No? Yes?
No, sir.
Give me a second. Okay, so I hope it's visible. So what Map My India does is they make a lot of maps. Am I audible? Hello?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Things coming? Okay.
Yeah.
So Map My India, they collect maps and they collect, it's free open source map, but they can add features to it. And the features only they have. So they are very, sitting on a very big database of rich features. Okay. So can you do similar things at a small scale is the question. Geodemographic data, for example, people, students, those kind of data. Do you have a better data which you could sell for these branding industries? Swiggy, Zomato, those kind of things. Okay, I'm bringing Swiggy, Zomato a lot because a lot of people are using it, especially in the COVID. Initially, we were afraid of them. The food is no good or not. Now everyone uses it, so it is very good. They give hygienic food, and the quality is being checked. So real view is something that when you drive, it gives you a real view. The current scenario is the roads actually congested or not. That happens by having specific cameras in locations, or they buy the camera data from, for example, all your shops will have their security cameras. You can ask them to put another security camera where you can access the data and you can put it as a real view in your maps. So this is what real view is about. End-to-end technology solutions to solve critical industry challenges like automotive. For example, automotives have a lot of issues in fixing the smooth riding conditions for the country, and also it also gives very important connectivity challenges like Ola, Uber, etc. So, for example, Uber is a partner or a stakeholder, or they buy data from Map My India. You have the Google Map, you have other resources, but they have more features. Okay, Facebook for business, Apple, Amazon, Mercedes Benz, all these automotive industries are highly tied up, because when you start an industry, automotive, more than the car, the raw material supply is very important, and these raw material supply can be mapped and then given to them as information. Okay, so that those maps can give them very good profits, because they don't have to go and outsource these, they just buy it from Map My India. The next one is e-lock, finding decoded locations. So you see there the buildings, the red dots in the buildings, those are actually codes. It is not an address, because an address can have multiple errors and issues, whereas e-location can be very unique to that building, and that is a solution they're giving. The other company I would like to show is OMSAT Technologies, where it is a geospatial lab where they sell drone and satellite data as information. So they collect the data, they may be paying the drone data, they may be paying the satellite data, but they make agriculturally informative maps, or space specific location maps for climate change impacts, disaster resilience hub, etc. And they sell these to top companies. Okay, so the maps they make, they're selling to top companies on pay per use. So they give not only geospatial data but also information based on those data. So the creative industry is pretty open. Anyone can jump in, like entrepreneur thing. A lot of dashboards are needed. Creating dashboards, housing the dashboards on Amazon Web Services is kind of cheap nowadays. So you can do it from the comfort of your home. How you do it, how you want to sell it is very important. Dynamic user interface, make it more dynamic rather than static. If you make it static, only one person can control it. If you make it dynamic, everyone controls it, and that gives them a sense of usability, how they want to use the data. Okay, GIS analytics, AI and ML are very, very strong. You can use AI and ML language. You can collect these data easily and then apply high algorithms, AI and ML, to get better information out of your data, better classification of your GIS data, and automation, and etc. This one is a GIS analytics using AI ML. It classifies your buildings. It classifies the top of the buildings to collect the area. IoT and automation are these two, where you can sit from the comfort of your home. You can control your water irrigation by just looking at the sensors and the map. You can click which map location you want to turn on the pipe. You can click what data you want to take using maps. So this is how IoTs and information can. So to conclude, I'm more than 1 hour and a half. So GIS is a powerful tool to organize, visualize, analyze, and convert information. Many open source data is available. You need to read about it and select which one is suited for your particular application. Many applications need solutions. Okay, local solutions. Many problems need local solutions. So you think local, and then you can scale up from there. Okay, entrepreneur track, collecting data, cleaning data is very, very important. Providing solutions is important, and user-friendly solutions is important. Create maps which are showing your creativity and futuristic mapping, not just what others are doing. I'm going to do it for lower cost. That may not be long-term solution, but be very creative and think about the future. What is going to happen? What is the big need for data, etc. Because satellites are being launched till date. So yeah, thanks a lot. I'll be open for questions. I'd like to thank those who have invited me. All the remote sensing data platforms, because it is given for free. And you can contact me in this email if you have other questions. So thanks a lot. I'll take question and answers now. Thank you.
So thank you so much, sir. So the session was very useful and very informative. Now the participants can leave their queries in the chat box, or you can raise your hand. I will make you unmute. So during the presentation, there was one question, sir. How to access worldview satellite data set? Is there any provision for free access for students like that?
Worldview is a company. They don't give it for free. You can ask politely. I'll do a product, and then I will sell your data, and the commission goes to you, because they are a private entity. Just and there are vendors for it. Okay, so it is an international company, but they choose local vendors who can sell the data. So just type Worldview India vendor, and you will find it. But yeah, they won't give it for free, because their satellites are more expensive than the free satellites. So when they're a private company, you cannot get it for free. Any other questions? Hello?
Yes, sir. Dear participants, you can leave your queries in the chat box.
Okay, I see a question on how to map underground utilities like water lines, drainage lines, etc. That is a very important question. Thanks, Mr. Bala. And that is what the government also wants. Okay, so here is where you don't just rely on GIS, but you yourself can go and collect data with a sensor. It could be a robotic sensor, it could be some sensor that can go underground along with your GIS mapping. So I think what Mr. Bala is asking me is a very important question. Don't just wait for GIS. GIS doesn't just mean collecting satellites and other data, but also you can make IoTs or ICT small tools that can help in these kind of getting data, and then you sell the data to the government. Even the government doesn't have that data. Okay, if you go to them and ask where are the drainage lines exactly, they have old maps. They don't have the new maps, and that is why when suddenly there is a problem, they break up the entire drainage line and take it out. Okay, and they keep digging. So your GIS entrepreneur thing can help with that. I'll just take the questions from the chat. For the micro level, Mr. Likari or Mr. Miss, I don't know. But Danesh, for the micro level study, which types of high resolution data is freely available? So for micro level studies, which is lesser than 1 meters by 1 meter, you can use Sentinel, which is at 10-meter resolution. When you say micro, it's still, I don't know how big it is, but Sentinel 2 is really good at 10-meter resolution. Cartosats are good at 1-meter resolution, but some of the Cartosats you have to pay. Okay, so even ISRO data you have to pay. So when you ask World View and QuickBird, they won't give it for free, because even your Indian satellites are, you have to pay for it. And even ISRO people, to use it for ISRO data, they have to pay. GIS for urban design study, may I know the process? Shuhasini. So the process is, there's multiple problem statements within the urban design. Do you want to make a garden for the urban? Do you want to make waste collection for an urban system, which Mumbai has asked us recently? And we are collecting the data, we are making the maps and placing the bins in a logistically good location where it quickly they could collect the dump and then clean it faster. So it depends on urban design. What do you mean? What do you want to do in urban design? If you want sustainable living, then there is a GIS maps that you can make for that. If you want living with the nature, those kind of urban designs, then you can make designs with parks, with water, with wetlands in that. So those kind of things you can look at. Okay. Yeah, I think those are the questions I see in the chat box. If there's any other questions, let me know, or you can ask the organizers. They can.
Sir, one more, Shuhasini. GIS for urban design study. May you know the processing, the steps they are asking, I think so.
Okay. So I just explained now. It depends on the urban question you have. It could be setting up multi-community solutions, wastewater solutions, connections to the urban system. For example, someone asked about the underlying pipelines, underlying wastewater sewage connections. Those can be mapped and then given into your specific solutions. Okay, in your urban design. Sorry, I'm not sharing my slides because it is just question and answers. If you want, I can pull down these slides importantly. Yeah, any other question?
So there is one question, sir. User-friendly GIS, whether it's QGIS or ArcGIS.
To be honest, ArcGIS has a lot of tools in terms of clicking easy and doing it. But the system is pushing to open source. Okay, so the government is pushing, because it's very expensive. It's very expensive ArcGIS, and it is. I think the government spends, just as a budget. I'm saying the government spends 10,000 crores on proprietary software, not mapping alone, but all proprietary software per year, and that money could be saved to use for others' resources. So Yes, user friendly. ArcGIS is pretty well good and user friendly, and that is why you pay. But QGIS is picking up also. So Dr. Narayana Swami is asking how to access groundwater condition of the particular area. You can access the data from WRIS India. I'm just going to put it down in the link, and then you can get all the data for entire country, your climate, your groundwater, any other data you need for water. You can get it here with geolocations. Okay, so you can just take the maps. Okay, I'll also put you a tutorial on how to download this data. There is a good tutorial, free tutorial downloading data. I'll just add. Okay. It's in the chat box. I'll just put it.
Yes, sir. Somebody asked your YouTube link, sir. Your anything recording video. Starting itself, they may
Sorry.
asked. Sir, your lectures on any YouTube channel, sir, in your.
Oh, okay. For entrepreneurs, we don't, because there is a lot of you know uh, once you do that, then there'll be focus of guiding is very limited. Mentoring. Okay, so normally you don't have entrepreneur videos for it, but specific problems, specific tasks can have a lot of YouTubes. Okay, for example, if you want to do just road network mapping, or like Bala's question about sewage mapping, you can get into YouTube and there are tutorials how to do it. But most importantly, what I'm trying to say is, don't just rely on GIS from remote sensing data. Try to see if you can make small sensors, and then you collect the data and add your data to the GIS map. It is called value addition. If I go back to my slide, I showed a slide on value addition. That is the key for getting your maps out. Okay, so yeah, make sure this is very, very important. Okay, and how you fuse your data, how you get your data. This is what gets you the money. All this is free. Okay, anyone can do it, but what is your value added processing is what differentiates you as a company. And that could be by, this is just for GIS, but that could also be by sensors, putting values on meters, etc., etc. For example, Domino's, okay, pizza, their delivery box is patented. It is a very unique delivery box because it keeps the food warm. But do we know how warm the Swiggy, Zomato are? Can we put a sensor in and say what is the best route to take the food warm? Because at the end of the day, you want your customers to be happy, and that happiness can be monitored through a temperature. For example, I would like my food to be kept warm until it arrives. Otherwise, the taste is gone. I think mentally, I think. Right? So that is the aspect you need to think about. Anything else?
Sir, one
Then
more
civil
question.
engineering practices GIS, IoT, ML, etc. does need domain expert like IT? No. So as a company, you should feel where you are comfortable. For example, most of the IT, most of the GIS entrepreneurs I have, they are all IT persons. Okay, they don't have civil engineering background, but they give their expertise on IT. So you can have, as a company, if you are a civil engineer, you can focus on the civil engineering part of GIS, whereas the AI, ML, and other data in IT person. So you pick and choose your partners based on your company aspects. Okay, good. Thanks for all the questions. I really appreciate your time. If there's anything else, please put it to the workshop organizers, and I'll be happy to give any clarifications. Thank you. I have to run for another meeting. Is there anything else? Okay.
Yes, sir. Thank you.
Okay,
Thank
sir.
you so much, sir.
Thank you so much, sir.
Okay. Thanks a lot. Thanks a lot for inviting me. Bye.
Yes, sir. Thank you so much, sir.
Thank you, sir.
Dear participants, now going for break for lunch, then again join back by 2:15. Afternoon, we have hands-on session on QGIS by Professor K. Kanmani ma'am. We're going to share the hands-on session materials also.
Dear participants, there is no attendance link and all. We'll be tracking your attendance from the Microsoft Teams itself. Okay. So the feedback link will be posted at the end of the presentation or end of the program. Okay. No daily feedback link. At the third day, you will be posting the feedback link. At that time, you can post all your feedbacks in that feedback link. Any other queries? We will again meet for hands-on training at 2:15 p.m.
Yes, we will share SAS PPT through mail, or I can share in Telegram groups we will create it for 3 days our certification program. So you can use from that.
Actually, we have prepared the hands-on training manual. Afternoon session, we will share those PDF so that you can also have a hands-on training after my presentation. Yeah, you can leave now, sir.
Yes, all of you can leave now. I shared the Telegram group through registered mail. Can you check your mail? Otherwise, I will share now. Just a minute. So, Telegram group link. Those who are not joined, please join. I will share the PPT materials from our expert, so I can easily share through Telegram group link. Any more queries? So all of you can leave now. You can take your lunch and come back by 2:15.